Shall we start the program, sir?
Yeah, can you see my screen?
Yes, sir, it is visible, sir.
Okay, is it in the presentation mode?
Yes, sir, it is.
All right. Yeah.
So, good evening, everyone, and a very warm welcome to all the participants, all the faculty members, and the expert eminent speaker for the session 7th of the day 4 of our AICT Atal sponsored faculty development program on driving the future sustainable mobility through electric vehicle technologies and MATLAB simulations. Today, we continue our insightful journey into the core technologies shaping the EV ecosystem, and it is indeed a moment of pride as we introduce a highly enriching session on the crucial theme that is the power electronics and BLDC motor simulation. We are honored to have with us Mr. Ramana Anchuri, an accomplished engineer from the education team at the MathWorks, who has been deeply engaged in supporting academia across India. Mr. Ramana completed his BTech in Electrical and Electronics Engineering, followed by the Masters in Power Electronics from JNTU Hyderabad. His professional journey spans both academic and industrial domains. Before joining MathWorks, he contributed significantly as a senior software engineer at KPIT Pune, working on control design for automotive engine systems. He also served at Cent Limited, where he developed, verified, and validated aircraft engine control systems. His area of passion and expertise include power electronics, control design, model based design, and code generation. With a strong inclination towards the teaching and learning, he continues to inspire and empower learners and educators across the country. So, we are truly grateful to have you with us today. Your deep industry and academic experience, especially with the control systems and model based development, will undoubtedly enrich our understanding of the BLDC motor simulations and the power electronics in the EV applications. With great pleasure, I now invite Sir to take over the session and guide us through today's topic.
Yeah. Thank you, Dr. Preeti.
Thank you very
Hello,
much.
everyone. Good evening. So I'm not aware how many of you are acquainted with MATLAB and Simulink. Before I start, can you quickly give me a show of hands on how many of you are familiar with MATLAB and Simulink? You can click the hand gesture. Okay, I see a few hands. Okay, you can clear your gestures now. I'll be asking a few questions in between, and I hope everyone is online and listening. I hope everyone is focused. I understand a few people are probably on their way home after your long day at institute or university. You might be having so many other things to take care of, but I'll keep it more engaging, and I'll mention a few of things that will be really helpful for you to teach these concepts and probably can help you to do research in these areas, right? We understand that many of your institutions and universities do use MATLAB Simulink, especially as part of labs, as part of projects, etc. Right. So one of the crucial thing, and this FDP, the title itself shows it's more around electric vehicles, and it's nothing new. And we are seeing in the market already these vehicles running on Indian roads, and it's gonna build up, right? Uh, so in this session, we will look into power electronics and BLDC motor aspects of it. But towards the end, probably on Saturday evening, we'll bring everything together and look at system level simulation of electric vehicles, right? So that will address the issues around what happens when you integrate all these components together, right? They might expect a very different behavior when you are testing these components individually. So we we will focus a little more on systems engineering aspects and how MATLAB Simulink can help you to draw and optimize system level uh, electric vehicles, right? So we focus on two things in this session: power electronics and BLDC motors. But before I go through that, let me give you some motivation behind why these things are important, right? Uh, Most of you know how Tesla has been revolutionizing the transport sector with electric vehicles, not just passenger, but high level off-road highway vehicles with which are solely used for transportation, right? So one of the engineer in one of the interviews did mention that they have been using MATLAB models to analyze how the power flow is from battery to the wheels and where is power loss and how do you uh, minimize this power loss so that whatever the power that you save directly reflects the range of the vehicle itself, right? So this engineer did mention they've been using for the past 10 years. 10 years is huge, and they are looking at how to make power converter efficient, how to make motors more efficient, so that whatever the power you save can reflect in the range. If you look, if you want to learn more about what this engineer mentioned, there is a link that I'm providing. I will share all these slides with you, but you can check this link and read more around how Tesla used MATLAB. Right. So if you look at the challenges of electric modeling electric vehicles itself, right? As I mentioned earlier, uh, as an engineer, probably we are focusing on a particular component in electric vehicle. But when you integrate your battery systems, power converters, motors, rest of the body of electric vehicle with body control, electronics, etc., the total vehicle efficiency, to calculate the total vehicle efficiency, it's very hard unless you have an entire system as a model, right? That's one of the challenge. The other thing is as new technologies grow, for example, power electronics, switches, typical IGBTs and MOSFETs at times might be replaced by silicon carbide devices, right? And we are moving towards more high voltage batteries uh, because they offer certain advantages, but at the same time you need to make sure that they are properly insulated, properly ventilated, etc. So as the technologies grow, it's very important that how do you analyze each of these components so that they are meeting the requirements. The final thing which is very much important is when you are moving from prototyping stage to production stage, uh, then the problems come up, right? So having production mindset while prototyping really helps you, and following the process really get you to the final product with less hiccups, right? So what I mean here is the process is, if you look at automotive industry, it's not just about the software that you create that is going to the electronic control units, but rather how do you make this software as safe, and is it following certain regulations, right? So it's not just about the algorithm itself, but you also prove that the software is safe, right? So on that note, there are so many processes laid out like ISO 26262 that that looks at functional safety aspects. Typically, these are not taught in universities, but we highly recommend students at least get a baseline understanding of what are the processes in the automotive companies involved when they are developing their products, right? If you want to learn more about these processes, please feel free to reach out to me. I can help you with one particular course on functional safety that you can roll out at your university. Right. So when it comes to system level analysis, what it takes is you need to have a model that mimics the behavior of a system, right? Not just a particular component. So in this case, on the right hand side, you see there is a library that allows you to build an entire electric vehicle system, including a drive cycle and driver behavior with vehicle dynamics and drivetrain. and you analyze how this vehicle is performing for a given test cycle. Right? So powertrain block set, vehicle dynamics block set will enable you to build these system level models and analyze the behavior or the performance and efficiency of the car against the standard drive cycles. Right. So what we need to accomplish this is the model-based design with Simulink. Right. If you are already using Simulink, in some way you are practicing model-based design. For people who are not aware, model-based design refers to expressing your models through graphical approach where there are blocks that mimic certain mathematical, logical, and physical behavior. Whatever the action you do on these models, these are ground truth and these are centric. Suppose say you are designing something, you create these models. You are expressing some executable specifications. The models enable you to do to specify these executable specifications. You can test and verify these models and also generate code out of these models and deploy to hardware. Right. So once you have the models realized, then they are centric to whatever the task that you do later. Right. The right hand side, you do see a simple DC motor that is built with Simscape Electrical, and it is being controlled by a PID controller with a set of references. Right. Once the model is created, you can generate code out of the PID controller block and target any microcontroller. Right. So right from requirements to design to code to deployment, Simulink offers a platform to do or perform all these tasks. Now, there are various ways in which you model these systems. Typically, are divided into first principles and data driven in a broad spectrum. In first principles modeling, it's all about the math behind these models and how do you express this. Right? A little lower first principles is physical networks. This is where you make use of you know a way that you do in your labs where you play with resistors, capacitors, and inductors. You can play with physical networks in simulation environment, just like how you do with breadboard and components. The other aspect is data-driven modeling. Here we rely on data rather than the math behind the models. You can go with statistical methods or system identification or neural networks. Now, whatever the modeling approaches that you want to take up, MATLAB provides various ways or workflows to do this. There are block sets and toolboxes that enable you to go with any of these modeling approaches. One approach that fits in between first principles and data-driven modeling is the parameter, the white box, gray box modeling we call, which is called parameter tuning. So here in this case, you can come up with math models and or physical networks of your realistic model, and to parameterize the specifications in the blocks, you can perform data-driven modeling to tune those parameters in physical networks or on math models. Right? But irrespective of the modeling approach you take, MATLAB Simulink provides you a way to model systems. When you look at the block diagram approach using Simulink, I know most of the professors do practice this as part of control systems or motor or electric machines courses, right? It's basically you realize the equations behind the current and the speed of a motor, and then later design these equations using Simulink, right? So here you're performing mathematical modeling. There are equations that mimics the behavior of a DC motor. The problem with this mathematical modeling is you are taking some assumptions that uh, there is no heat generated by this motor when it is loaded, which is not the case practically, right? But if you want to include the temperature effects of on the motor behavior, it it becomes very hard to derive these equations. It's possible, but it's very hard, right? So at times when systems grow in complexity, mathematical modeling becomes very cumbersome and might take a lot of effort and time, right? So on that note, one of the quickest ways you can realize is through physical networks, right? Now, physical networks, on the background, they do work on certain physics or the equations, but you yourself need not express this the behavior with mathematical equations. So what I mean is Simscape allows you to model physical networks. For example, if you want to mimic the behavior of a resistor in Simscape Electrical, you can pick the library block resistor and then use it for simulation and analysis. The other aspect is you can also perform nonlinear behavior. For example, in the previous mathematical modeling, when I told, can you simulate the temperature effects? It becomes very hard. It's possible, but becomes very hard. Using Simscape, you can perform multi-domain modeling. I can integrate the thermal behavior to an electrical system and then simulate both electrical behavior and thermal behavior of a system. Likewise, once you realize thermal, the next step is you want to look at the cooling the system. Now you can integrate the thermal liquid or two-phase fluid uh, domain to the electrical and thermal models, and then uh, do a behavioral analysis on when the heat is liberated. You can probably switch on a chiller, which will reduce the amount of temperature, the value of temperature your system is generating, right? So in a way, it's sort of a multi-domain modeling environment, and you need not worry about the math behind this. That is already realized with these blocks, and you can quickly build multi-domain systems. This is important because most of the time students are taught, electrical students especially, are taught about only electric systems, but not much around thermal and cooling aspects. In real world, those also becomes very important, right? So Simscape enables you to do that. Not just this, you can convert the Simscape models to C code and deploy it onto an FPGA to perform hardware in loop simulations, right? So that way, instead of accessing a physical asset, you can have a simulation model of your physical asset, deploy it onto a real-time controller, real-time on a real RTOS compatible machine, and then perform a hardware integrated hardware in loop simulations, right? This way, you can also get confidence that your control algorithms are going to work in real time, right? So if you haven't explored Simscape, I highly recommend you please look into this. There are so many examples that can help you to quickly get started. Now, with physical systems, as I mentioned earlier, typically this is how you see motor in your lab, and you can express this physical model using Simscape electromechanical system. So on the left hand side, you do see the electrical network. On the right hand side, the mechanical. Okay, and all these behaviors are modeled through blocks. A resistor and inductor is basically uh, exhibits the voltage drop aspects, back EMF aspects, while the mechanical system will enable you to model the motor inertia, the damping aspects of it, right? You can simulate this and quickly analyze what's the current taken by the motor for a given load, or what is the rotor angle, etc. So it's one of the quickest ways to get to the model behavior. This is how realistically it looks DC motor in Simscape. On the left, you do the blue color block diagram represents the electrical system, and the green the mechanical system. Each domain has its own reference, as you could see, and your system needs to be connected to a solver, the solver configuration. So how is this different from mathematical modeling is when you write equations and then quick hit run, you're actually solving ordinary differential equations. In this environment, you are solving differential algebraic equations. What that does mean, what does that mean is, if you look at this loop, okay, you can perform Kirchhoff voltage law (KVL), and you can prove KVL, the physical in the simulation environment. So all physical laws holds good when you are using Simscape. If at all you are using mathematical approach, then it's just equations, and you can't usually do that. So what this means is when you are in this environment, you can consider current is actually flowing through these lines, right? So in a way, this modeling construct exhibits a behavior that you see when you integrate components in the lab and power them, right? So you can bring that experience while you are modeling using Simscape. Once you do the model of the motors, then it's all about how do you come up with a control mechanism. On that note, Simulink control design, control system toolbox will enable you to tune this PID controller pretty easily. You can start with a trial and error method and then see the response of the motor. But there is a very quickest way where you can auto tune the PID gains pretty easily with a single click of a button and realize the controller, right? There are various ways to tune this. We will look at one of the most difficult method to tune a PID controller for a non-linear plant. If your plant is linear, you double click the PID controller, click on hit tune, it will give you the tuned gains just like that. But if the plant is non-linear, then we need to go through a data-driven modeling approach per plant and then apply the PID tuning to it. We'll look into that when we get to the power electronics converter tuning. Okay. So let's look at the brushless DC motor. Now, previously, we have seen the simple DC motor, but this is a special purpose DC motor you can consider with permanent magnets. And you need to fire the windings of this particular converter appropriately by knowing the rotor position at every given point in time so that the action keeps going. Okay. Typically, if you look at the back EMF of the BLDC motor, it is trapezoidal in nature. People usually consider if it is a trapezoidal back EMF, then it is BLDC. If it is sinusoidal, then it is PMSM. But whatever, you can easily analyze the behavior of a BLDC motor in Simulink environment. We do have a lot of blocks that are already created for you, wherein you can drag and drop a BLDC motor block and then integrate rest of the systems with it. So the thing with BLDC motor is it always needs this front-end inverter. Why so? Because when you have a permanent magnet which is rotating, you need to fire these three-phase windings appropriately so that either attraction or repulsion happens and then the motor keeps on rotating. But to do this, we should always know that where the rotor is at a given point in time, right? So here, if you see the power electronic converters are being switched so that you do see a three-phase currents that are getting into these windings, wherein the reaction happens and the motor rotates. Right? So it's very important that the motor is always having a front-end inverter, and you need to develop a logic so that these are fired. Now, when you are firing this power converter, it's not that you are controlling the speed. You are only making the motor rotate, right? Nothing much you are doing. Okay. Now, when it comes to speed control or a torque control, then you have to employ control techniques on top of this behavior itself, right? So, nutshell, if you want to make a BLDC motor rotate by giving power, you definitely need a front-end inverter. So this is what the logic is all about. As I mentioned earlier, we always need the knowledge of where the rotor is. That's why you need a rotor position sensor. And that goes to a commutational logic. Typically, you can consider this inverter as a commutator in a DC motor, but there it is hard switching and you're doing soft switching through power converters, right? So we have this commutational logic that enables these switches to fire at right points based on the rotor position, and that keeps the action going, right? So it needs a DC voltage definitely, and then it's converted into three phase through this inverter, and this commutational logic need to work. Right? So what does this mean is the motor itself cannot rotate when you power it unless you make this commutational logic work. So to perform speed control of BLDC motor, again, there are so many examples that we created. We highly recommend you, if you are starting up with understanding these controls for BLDC or PMSM or induction motors, we highly recommend you to have a look into basic examples around these motor controls. Okay. One such example is this. As you could see, the blue colored blocks where whatever you see, these are electrical systems. Okay. I have a fixed DC voltage that I'm passing through an average buck converter, which enables me to get a variable DC at the DC bus here. And this inverter is nothing but that front end inverter that I spoke previously, which enables the commutation logic for this motor, right? So we have two controls here. One is this particular inverter is making sure that the motor rotates, and this buck converter is actually generating a variable DC so that the speed of the motor can be controlled, right? So the inverter is solely there to actually have that commutation logic working. This buck converter is responsible for the speed control. Right? Now, if you look at the mechanical side of it, so there is a mechanical reference connected to this, and we have defined the rotor inertia, and there is a sensor. There is a torque source wherein you can apply input to torque input, and then torque input is nothing but you're loading the motor, right? So that loading the motor, that torque is generated by this particular test signal. Okay. So here you're specifying the speed reference and also loading the motor, right? So all in all, this particular example will make you understand on how do you control speed of a BLDC motor, just the speed. Now, if you look at it's the control techniques, right? It's you don't just use the voltage to control, right? Because in scalar control, you can't get better torque performance, and you can't precisely control the motor speed, etc. Right? That's why you resort to most popular control architecture, which is field-oriented control. Okay. So in this case, this is a physical system wherein you have power supply, the converters, inverters, and the motor. You have the current loop, inner current loop that works at a higher sample rate. And then there is the outer speed loop, which is a little slower compared to the current loop, right? So in this case, our idea is to generate a three-phase currents and enable this inverter working. What's more important is you convert these three phases to IDIQ, and which are direct and quadrature axis currents. And each of these currents decouple the speed and the torque. So that means you can use one reference current for controlling speed without affecting the torque, and one reference current you can control torque without affecting the motor speed, right? So PI controllers are needed, yes, and You can also tune these gains of the PI controllers pretty easily through Simulink control design workflows, right? So all in all, irrespective of whatever the type of motor here, be it a BLDC, PMSM, or induction motor, uh, this control architecture will work. Only thing that you need to take an extra caution when you are using BLDC motors is the front end inverter is needed to keep the action going. All right. So this is one case. This is a four-phase PMSM motor, and there are five-phase and three-phase PMSM motors also that you can use. But this example refers to the four-phase PMSM motor, and you have a converter, torque and load references, and you can define that through a mat file or by just drawing through mouse. And here you see the PMSM parameters here. The one thing that I often get asked is how can we parameterize this? How do I know LD, LQ, RS of my PMSM motor, right? One quickest way is the manufacturer of the motors will give you the data sheet, and the data sheet provides all these values. If not, there is a way to uh, estimate the parameters of the motors by running a simple test on the motors. If you are interested on parameter estimation, please look into certain examples where you can directly use Texas Instrument boards that are integrated to PMSM motors, and you can perform a quick estimate motor parameters exercise, which will give you all these values, right? Then, as I mentioned, we need to have a rotor sensor, and what you need to do is hit run, and the model compiles and gives you the results. If you look at the scope here, I am trying to see what is the speed of the motor and what's the torque reference and torque measured. Now, in the initial phase here, I'm keeping the speed constant. I'm varying the load. And if you see, my motor is able to generate torque that I wanted. Okay? And the torque reference and the actual torque are same. Now, later point in time, I'm varying the speed. Okay. And speed is varied, and even at a different speed, when I change the load, it is able to capture the or it is able to follow the reference torque. Right? So this proves the control technique is working fine. You are making these reference changes, but when the load is changing, you are able to maintain the constant speed at different speeds. Okay. So how is this done? It is done through C2000 microcontroller block set. Okay. So we very recently released the C2000 microcontroller block set, where C2000 boards are coming from Texas Instruments, and you can design the motor control algorithms using Simulink, simulate the behavior, and then later implement this code onto the hardware with a single click of a button, and you can deploy these models standalone and run the motors. Once it is deployed, you can just disconnect the motor USB port and run the motor standalone. It will not have anything to do with MATLAB and Simulink later, right? So in this aspect, what we are typically need to do is first thing is we need to calibrate the sensors, because sensors might have some noise, and initially we never know where the rotor position is. So we need to calibrate the sensors. If needed, you can estimate motor parameters if you do not have an idea of what the motor parameters are. If there are data sheets, then you can also estimate motor parameters. You can model motors and inverters and design the control algorithm and then deploy, right? So motor control block set will enable you to do all these steps from within Simulink environment. Okay. So what is needed is for modeling motors and inverters, you need Simscape Electrical. For designing control algorithm, Simulink control design. And for deploying, you need coder products. If you are deploying C++ on a microcontroller, embedded coder is needed. If you are targeting FPGAs, you can generate HDL code also. So how does it work? So there is once you configure your model for hardware, as you could see, the hardware board here is TI Delfino F28379D. This is very popular and latest board. We do see this launchpad in many of the universities too. The build, deploy, and start will enable you to generate code out of the model directly, C or C++ code, and it will invoke the Code Composer Studio in the background, generate the bit file, and deploy it onto the hardware. Right? It's just a one click where you can translate this model to run on the hardware. You need not struggle or put your efforts in understanding the code. Anything that you want to modify with respect to your algorithm, you can do it at a model level. The rest of the things are taken care. Not just Texas Instruments, but if you're targeting a different microcontroller like Microchip, NXP, STM, Infineon, there are ways we support. There are support packages for each of these hardware boards, which you can install for free and use Simulink to model the algorithm and deploy it onto the hardware. One of the latest things we have been observing is people are also interested in deploying motor controls on FPGAs. If you are interested, we can support you in deploying these motor control algorithms on Xilinx Zinc platforms, which offer pretty high performance compared to microcontrollers. Any questions till now before I move ahead? I'll just look at the chat if there are any.
Dr. Javed sir has raised the hand, sir.
Yeah, Dr. Javed, go ahead.
So can you explain about the C2000 model? What is that?
Can you again repeat the question once again?
So what is that C2000?
Okay. So C2000 is nothing but a family of microcontrollers offered by Texas Instruments. Texas Instruments is the semiconductor company that manufactures chips and launch pads. Okay, and these chips usually go on to the real world products. Okay. What you see on the top left, red color launch pad and a PMSM motor here, the launch pad is F28379D, which is from a C2000 family of microcontrollers.
So we can save the code inside of this chip.
Come again, sir?
Can we save the code inside the chip?
Yes. So previously I did mention here. Let me just go back. Yeah, if you see on the right hand side, right? Okay, that's the code generated by Simulink, and you can actually see the code. It's completely up to you. And if you want to make some modifications on the code, not recommended, but you can still do it.
Is it require any addition type of software installed for the MATLAB?
You need to install Code Composer Studio from Texas Instruments. They will provide you.
Okay, thank you, sir.
It's a compiler. It's a compiler, and you need that. Okay. Yeah. Thank you for the question. Any other questions? You can write in the chat if you are not able to talk.
Mr. Vinay sir has raised. Yes, sir, please.
Sir, I have one question.
Yeah.
Sir, whenever Code Composer Studio, I am dumping my code. So how I can integrate with a MATLAB, sir? The Code Composer Studio and the MATLAB will be compatible to download the code from Composer to that controller side of MATLAB through controller.
Yeah. So what we offer is when you are installing the support, right, the microcontroller block set or C2000 block set, you need to perform certain actions in terms of installing some packages from Texas Instruments. Okay, Code Composer Studio is one part of that. Without that, the code generated by Simulink cannot be compiled and deployed onto hardware. So in the background, when you have a Simulink model, when you hit on build, deploy, and start, what happens is the code gets generated. That's one thing. The code is getting generated through embedded coder, but it will invoke Code Composer Studio in the background, and it compiles the code generated by the embedded coder in Code Composer Studio as a project, and then generates the bits, basically the zeros and ones, and deploys onto the hardware, right? So it's not standalone like only Simulink doing this job. Simulink is generating the code, Code Composer Studio is compiling that, and then deploying onto the hardware, right? So all these are minimum requirements to make the hardware work.
Sir, in that part, whenever I'm implementing any particular Simulink model, they can easily implement that thing into a embedded coder. Whichever the Simulink model I have developed, they easily getting to be convert that particular part to a embedded coder.
Yes, Simulink. If you have a Simulink model, yes, you can translate that into C or C++ code. Yes.
Okay, okay. Thank you, sir.
Yeah. Any other questions? Okay.
No, sir.
All right. Let's move to the power converter part. So here, power converters are basically needed because your load requirements could be different at different point in time, and probably sometimes your input is AC and you want DC, or your input is DC and you want AC, or your input is unregulated in case of solar panels, and you need a device that looks at the load requirements and then sends the power accordingly, be it in AC or DC form. Okay, so what it needs is you need a sensor that always observes what's the power voltage and current or the power going to the load, and then with respect to the user set references, you generate certain pulses and control this power converter, right? And at times this converter could be pretty complex in nature, not just one switch, multiple switches, and you will have components like inductors, capacitors, resistors, etc. Right? So why is this important? Okay, if you look at some high-end cars, one of the use case, automotive use case, where there's a very high performance power converter needed is this one. This is a Mercedes-Benz E-Class car. So this particular one has an adaptive headlamp technology, wherein these LED strips are lit adaptively based on what car camera is seeing, right? So what it means is the opposite vehicles will receive less glare, and at the same time you'll have a better visibility of the road, and you can also control which LEDs need to be lit so that the glare is minimum and at the same time your visibility is not lost, right? So to perform something like this, we need a high performance power converter that can power these LEDs adaptively based on some sensor information, right? So what it takes to build a technology something like this, again, this is from Texas Instruments. This is called Texas Instruments DC-DC LED kit. So what it has here is an LED strip that is integrated through drivers, and this is connected to a power converter here. Okay. So this is a DC-DC power converter, and it's famously called SAPIC. Okay. On the right-hand side, if you see the block diagram, this is basically a single-ended primary inductor converter. So this is the primary inductor at the source end, and this is responsible for boosting the voltages and all. And why it became very popular is if you look at the source and the load, the source and the load are so isolated by an LC stage, right? Inductor and a capacitor. Right? So this offers a good isolation between source and load, and the load and capacitor will reduce the voltage ripple. And whatever the strip LED strip you are seeing, this is the jumper wire, and you are connecting that to LEDs through MOSFET drivers. These are MOSFET drivers. Okay. So this is the kit, which is nothing but this power converter, and the jumper is this red wire, and it is giving the power to LEDs through a MOSFET drivers, which are nothing but this. Okay. The heart, not the heart, the brain of this particular kit is basically this control card, and you need to program this control card to generate pulses for this MOSFET that directly controls the voltage applied at this node, and also control these MOSFETs so that different LED strips are lit at different point in time or with respect to some sensor data. Right. Now, why it is important is usually students are lost in terms of where are these power converters used, and use cases like this might inspire them to learn more about the converters. Okay, so this is the block diagram taken from the data sheet itself, and using Simscape, you can translate this block diagram into an executable simulation model, right? If you look at here, I have a simple 12 volt, the inductor block that mimics this inductor behavior, the isolated capacitor, the voltage is, I'm just replacing that with a simple DC voltage source. And what extra you see is basically the sensors, the current measurement, voltage measurement. Okay. And I replace the MOSFET with an ideal switch here. And I can pass a duty cycle to this, which generates the pulses accordingly. And then you will receive the output voltage. Okay. Here, the load is replaced by a resistor. LEDs, you can probably consider that as a resistive load. And then you can just have the resistor as a load here. Right. This load and capacitance will reduce the voltage ripple. Right. Now, I did mention when I was introducing Simscape, you can consider this blue color lines as electrical connections. You can apply KCL at this node, and all the values that you compute will conform to Kirchhoff current law. Okay. That means whatever if at all you are doing this on the breadboard, it is equivalent when you are doing on Simscape. Okay. So what Simulink offers is not just modeling, but you can execute this model and then see the response. So if you are wondering where I pick these models, you can use Simscape to model the electrical systems. You can just go to Simscape electrical elements, drag and drop this onto the Simulink canvas, and then double click on this to parameterize this block, right? So if you see here, the Simscape block itself is giving you a little more information. It's not just inductance you are specifying, there is series resistance and parallel conductance. What does this mean? You can model a realistic behavior of this inductance. And if you want this inductor, if a particular current is flowing and you want this inductor to behave like a saturated inductor, you can also change to that, right? So that means you can emulate the behavior pretty close to what you see in the lab. Now here we'll look into the modeling constructs as such. So what we have here is a 470 microhenry inductor, and then the load and capacitance is 950 microfarad. These two basically impact this converter pretty much. If you go wrong in picking the right value, you will go wrong with whatever the voltage is, or whatever is happening on the source end will go wrong, right? How did I get to know about these values? These are from datasheet. Okay. But typically when you are developing your own converter, you never know what's the value of the inductor and capacitor that you need to pick up, right? Now that's the problem. Okay. So to do that, we'll look into that. How can we optimize the values of capacitors and inductors of a power converter? But right now I just have a 50% duty cycle. I just use the datasheet parameters and able to simulate the model. Okay, so here in this case, LEDs are replaced by the resistor. Okay. So in the previous case, you got some overshoot initially, but the voltage stabilized without much ripple, right? And this is the response I got directly when I'm using the datasheet parameters. Typically, you never know if you are actually designing your own converter, and silent error method will be very effort intensive. You can't do that with physical capacitors and inductors. So one way of doing that is through simulations. Okay, so here we, instead of going with datasheet parameters, let's just change the inductance to 10 microhenry instead of 470, and then do the simulation. Now, when you do this, I am not receiving any ripple in the output voltage, right? Which is good. But if you look at the input current, and then zoom in on the input current, then the behavior is not what I see. What I would like ideally need to see is a continuous current, but this current is going below zero and negative for certain amount of time. That means this converter is operating in discontinuous conduction mode. Okay, so we usually teach students these aspects: continuous conduction mode, discontinuous conduction mode. Changing simulation parameters, you can explain these phenomena pretty easily using SimScape, right? Now, the problem with discontinuous conduction mode is if it is LEDs, they might exhibit flickering. If at all you are employing this converter to run a motor, there will be torque ripple, there could be noise generated and all that. Right? And you're actually polluting the input side also, right? So the power factor will reduce, and you end up using more current for a particular performance, right? So this is not desirable. But although you see the output voltage ripple free, but the input current became discontinuous, right? So picking the right values for inductors and right values for capacitor is crucial, right? So simulations will enable you to do that analysis very quickly and then arrive at optimal values. So what we did is we use simulations to design the parameter values for these components, and you have a scope to optimize the component sizing through the analysis, right? Typically, people will end up designing their own inductors and then rely on capacitors that are available in the market. Through simulations, your effort will reduce because you can easily compute what value of inductance will be sufficient. More inductance can be used, but your PCB becomes bulky because you will end up having more turns, more weight for the inductor, more space, and all that. Right. So you can optimize the component sizing using simulations. The next part is nonlinear switching behavior. This is also very crucial. In the previous case, I did use an ideal switch, right? But in real world, you don't use ideal. No switch is ideal, right? So I just replaced the ideal switch with the MOSFET here in this converter, right? You do see some differences here. So on the switch itself, one of the input is the PWM pulses that is going, and you have the drain and source connected to the electrical wire. But there is also this orange color, or rather gold color lines, right? This is for modeling the thermal behavior of the power electronic switch. Why this is important is we often tend to go at high switching frequencies because you can easily filter out high frequency ripple. But the problem in doing so is the switch generates a lot of heat. Okay, and this heat need to be regulated through heat sinks or force cooling, etc. Now, to do that, what should be the cooling requirement? To actually get to the cooling requirements, you need to model that behavior here. Okay, and that's what we did here. You can right click on any power electronic switch. Sorry. And then Simscape block choices, you can hit on threshold based thermal. Now you see a thermal port, which is H that is appearing. And using Simscape thermal, you can build the thermal behavior of this. Okay. So I'll spend some time on this to make you understand. When switch is operating at certain switching frequency, it generates certain heat, and that heat information is available at this port. Okay. Typically, as an user, you will express at what temperature your power converter is operating, which is nothing but the ambient temperature. Now, heat flows from a point which has more temperature to a point which has less temperature. Now, if this switch is generating more heat, then the heat goes from the node H to the ambient through a medium. Okay. Now, when the heat flow is happening towards the ambient, there will be some loss of heat while the flow is happening. That is modeled by a thermal mass heat sink. Okay, this exhibits a behavior where it sucks out some heat that is going from this H port to the ambient. Okay, just like how voltage drops when it goes through a resistance, the heat is lost through this thermal mass. Okay, and we have a sensor that measures the heat flow. And how is this heat escaping to the ambient is the convection heat transfer. So we do teach students about this heat sink design where the junction temperature is at a high temperatures, and then it goes to case to heat sink to ambient. Now you can model that entire behavior using Simscape thermal. Here we only had the convection heat transfer with one stage, but if you are interested and if you want to realistically model how the heat flow is from switch to ambient, you can do that with Simscape thermal modeling. I'll just pause here and check if there are any questions. Any questions?
So that model will not allow the temperature to increase above the limit.
No, there is no control over temperature here. Now, if you have suppose at 10 kilohertz to 20 kilohertz, you are moving the PWM frequency. Then compared to 10 kilohertz, 20 kilohertz will produce more heat from the switch. Now, depending upon what is the ambient temperature you specified, the heat flow can be from H to ambient or ambient to H. So this is what happens, right? If your room temperature is 25 degrees Celsius and the temperature at this port is 75, then obviously the heat flows from switch to ambient. If you want to analyze the power converter behavior at 75 degrees Celsius, you can change this ambient temperature to 75 and then observe. In that case, your switch will be at a more stress because the heat is produced, but again, the ambient temperature is also high. Okay, that means it will be at a more thermal stress. Right? So it depends on how much temperature you are specifying as an ambient temperature and how much heat is produced by the switch.
So can we implement any controlling device also that control the temperature?
Yes. So what I will do is I will connect this thermal port to a pipe, okay, using the Simscape fluids. You can connect this thermal line to a pipe and then flow and then force a coolant to the pipe so that, as I mentioned, thermal mass will actually sink some heat. That cooling pipe will remove that heat and then it will make the switch cooler. Okay? That behavior can also be modeled in the same platform.
Okay, one last question.
Yeah.
How you add the knob? You moving the knob that changing the value of L. How you add that knob in the MATLAB and how to do the mapping with the inductor?
Okay. So there's a library called dashboard, right? You can just type in Google Simulink dashboard. You will get a lot of help on that. You can use some dials, knobs, switches to control value in a block, to control the block parameter value, right? It is from Simulink dashboard library.
And how you add the graph on the life cycle?
That is also in the dashboard. There is a something called dashboard scope. Okay, you can use the dashboard scope and then link a particular plot to that, and you will see a plot that is pretty much embedded on a Simulink canvas.
Thank you, sir.
Yeah. Thanks for asking the questions. Any other questions?
Sir, I have one doubt, sir.
Yeah.
Sir, same circuit we can do it in Simulink also, right, sir? Any performance difference is there, sir? If you do it in Simulink, so what is the difference between Simulink and Simscape, sir?
Okay. Let's take first the first question. For modeling the power converter using Simulink, then that means you are referring to mathematical modeling. Okay. So you need equations that that cater to the behavior of this power converter. That's one thing. And typically, when you have equations that capture the dynamic behavior of a converter, you can go with Simulink. But the problem is, it becomes very hard. If I tell you, okay, there is this converter, and then write the mathematical equations corresponding to this converter, you can have very simple equation, or you can have very complex equation that caters to the thermal behavior also, right? If it is very simple equation, then you are not modeling the converter realistic behavior. If at all you are covering the thermal and everything, the equations become very complex, very cumbersome. You can't handle that, right? So our recommendation is, if you have knowledge of a system through mathematical equations already, which you don't need to derive, and relatively easier, and your assumptions doesn't matter, then you can go with Simulink way of mathematical modeling. If you want to develop multi-domain models, if you want to add more realistic behavior, the easiest way is Simscape. Because here, even though I am an electrical engineer, I have less knowledge around thermal engineering, I can understand what's happening with this model and then build that behavior, right? So if it is mathematical modeling, and if you feel that the assumptions doesn't matter, you have equations conforming to the dynamics of the system, go with Simulink. If you have a physical network or a block diagram, then Simscape is the easiest way. And the other thing is, if you want to perform realistic behavior of dynamic systems, Simscape will offer a better and fastest way to build these models. Hope I answered your question.
Okay, sir. Okay, thank you, sir. So we will get an accurate result in Simscape compared to
No, I won't give that statement. It's basically used for different use cases.
Anyway, sir, if we did the simulink in same in the Simscape model, we can did it in same in the simulink. We will get same result or different result. We will get same. Consider this circuit, sir. This circuit, I will do it in simulink. Result will be same or
See,
different.
Simulink, there is no concept of circuit, right? You are just expressing an equation with model, with the modeling blocks. Okay, it's basically mathematics. That's what you are doing there.
Just now you showed that waveform,
Yeah.
right, sir? Because of that inductance performance, that oscillation is there. So same oscillation will be occur in the simulink, or a different result we will get. Like that, I'm asking, sir.
See, that depends upon whether whether the equations that you have derived actually also takes care of that nonlinear behavior and everything. Okay, and usually it is very hard to derive equations with the nonlinearities and all that. Okay, so Simulink is for mathematical modeling. Simscape is for physical modeling.
Okay, sir. Okay, thank you. Thank you, sir.
All right. Any other questions? All right. Go ahead. So, not just about the model itself, you can also perform power loss, thermal behavior, and power loss constitutes switching and conductance losses. And you can also parameterize this entire MOSFET switch based on the device data sheet. Okay. Usually the manufacturer will give you the data sheet, and you can double click this MOSFET block and parameterize entire MOSFET. Now the crucial part is, how do you design control algorithms, right? So this is a closed loop control for a converter. I just replaced the MOSFET with a ideal switch for simplicity, but you can do with MOSFET also. Okay. So this block diagram, what we are doing, we are sensing the output voltage. We are comparing that with reference, and then we are passing the difference through a PI controller and generating a PWM pulse so that the output voltage is equal to the reference voltage set by the user, right? And typically this is the block where we can generate code and deploy it onto hardware, and that software will control the actual power converter, right? So what you can do is you can set the references first. So here I'm setting my below 0.4 seconds. I want the output voltage of the converter to be 12 volt, and after 0.4 seconds it needs to be 27 volt, right? That is the reference set by the user, right? Once this is set, then you can run the simulation. Here I did not tune the PI controller at all. It is just blank. Okay, it's just default values. But now when you see below 0.4 seconds, it needs to be 12 volt, which is something it should be here. And after 0.4 seconds, it should be 27 volt. That means this controller is not at all working. Okay, the label name is incorrect. Please read this as voltage, not current. Okay. So the output voltage is exhibiting certain behavior that it is trying to catch up to the reference speed, but it is not able to capture, reference voltage, but it is not able to capture the reference voltage. Now what we need is, we need to design the controller gains properly so that the reference and actual are same. Now to do that, what we can do is go to the PI controller block, double click on it, and then hit tune button. Okay. By default, the proportional gain and integral gain are 1 and 1. Okay. When you hit tune, what happens in the background is it tries to linearize the plant. What does it mean is, I did mention at the DC motor end, if your plant is linear plant, the PID controller block will directly give you the gains. But if it is a non-linear plant, then you need to go through a different methodology to tune the PI controller. So the flag it shows is plant cannot be linearized, and it asks us to identify a new plant using data-driven methodology. Okay, so I am going to walk you through a process on how do you rely on data-driven modeling to auto-tune the PI controller. Okay, so to do that, what you need to do is go to plant, go to plant, and then click on identify new plant. On the right hand side, you do see a new tab appearing, which is plant identification. Okay, and it is asking us to use the get IO data menu to identify the new model. Okay, so you need to go to get IO data and click on simulate data. You can set the offsets. I will let you know what these offsets and amplitudes mean. Now what's happening here is, if you see this image, okay, what Simulink does is it will disconnect the PID controller, right? And then just pass on a duty cycle to the switch, which is nothing but U, which is nothing but the input. We are passing 0.5, so that means 50% duty cycle, okay? And then it is going from 0.5 to 1.5. That means we are not using the PID controller at all. Instead, we disconnected it and we are just sending a step input as an U and then computing the error, which is nothing but this particular graphic. Okay. When you do that, here I am doing 50% duty cycle to 90% duty cycle. That means this U is nothing but the step input. Okay. With respect to this step input, I am computing the error, which is going as input to the PID controller. In this process, please make a note, PID controller is not doing anything. We disconnected it. We are just sending a duty cycle, which is nothing but this step input, and we are computing what is the error. Okay. So here in this case, we are using U as an input, E as an output. Okay. That means using this input and output data, I can identify a new plant model using data-driven approach. That is what is happening. Instead of using the same plant model which is on Simscape, I am relying on data generated by the Simscape model. Okay. Here in this case, step input is the input and output is the error that otherwise will go through the PID controller. Right. Once you do this, you can apply and then close. Now here, sorry. Now here what happens is, as the, one second, as the label indicates here, my identification data, that means the response of a data-driven model is the green color response. The plant I identified using the data is the blue color response. Now, definitely there is so much gap between what I identified and what the data is providing me. Okay, so you can use this adjuster and then reduce the gap. Okay, the other thing that I can see here is the transient response of the model is not being captured properly, right? That is because the structure that you are using to identify a plant model is only one pole. If you give more flexibility to the plant model, here we are applying underdamped pair of poles so that I can place these poles properly to map the plant that is identified to the identification data. But the problem when I changed the underdamped pair of poles, I did not place these poles properly so that the response is in line with the identification data. In that case, what I can resort is I can click on auto estimate. Okay. So when I click on auto estimate, what happens is it will place the poles properly at certain locations and then map the plant identified data to plant to identification data. Now you see my identification data and the identified plant are correctly mapped. What does it mean is you generated data from a Simulink model and you created a plant which exactly behaving like what you generated with the model. Right? Now I use this identified plant instead of Simulink model to tune the gains of the PID controller. That is what is happening. So instead of directly working on the nonlinear plant, which is the power converter, I am generating data from the power converter and using that data to identify a new plant transfer function, right? Once you do that, you click on apply. Now this plant is used to tune the controller. Now you got the response of the PID controller. You can also see in the bottom, the proportional gain is 0.2733 and integral gain is 38.05 that it came up with. Okay. Now, once this is done, you can see what are the parameters previously the block has, which is 1 and 1. What are the parameters after tuning? And you can also see all the performance and robustness parameters like rise time, settling time, overshoot, gain margin, phase margin, etc. Okay, this will give you more confidence that whether your system is closed loop stable. Once these gains are computed, now what you can do is use these sliders to make the response faster or slower, aggressive or robust using these sliders. Okay, once it is done, click on update block. The values that you saw in the previous process will get updated on the block parameter. Once this is done, you can click on OK and run the model. Now you see the response of the system. If you remember, I set the references as 12 volt before 0.4 seconds and 27 volt after 0.4 seconds. Now I can see the output voltage of the converter is actually following the reference voltage. So this is how you can tune the control algorithms for nonlinear plants. So you can use this analysis, use simulation input and output data, and then auto tune the control algorithm. Now the next final part is how do you deploy this algorithm onto hardware, right? Because we can't just stop with simulations, right? Now what MATLAB Simulink offers you is you can translate the control algorithm to either C or C++ if you are targeting microcontrollers or DSPs, HDL or Verilog code if you are targeting FPGAs or application-specific integrated circuits. Whatever it is, the model is same. Okay, you can generate or you can target any of these boards. Okay, right now our target is Texas Instruments DC-DC LED kit. You can take the microcontroller subsystem itself and have the interfaces ADC and PWM. These will come from microcontroller block set, C2000 block set. Okay, and these interfaces will enable you to communicate with the hardware from within Simulink. Okay, you need not write any device drivers for Simulink to communicate with the hardware. Okay, once this is done, one interesting way of verifying whether this control algorithm is working on the hardware is to run the simulations in external mode. What does this mean is, I have a PI controller subsystem here, and all the interfaces that are needed, I can run the simulation from within Simulink and also deploy the code on the hardware and read back the signals into simulations to verify based on my references whether the output voltages are changing, whether the particular LED strip is lit or not. All that analysis and verification can be done from within Simulink environment itself. So here Simulink is communicating with the board, and board is and we are reading back the values that are written on the board. Okay, so this we call as external mode simulation, and you can run it in tandem. Right. Once you are satisfied with the results, then you can click on build, deploy, and start. Once the code gets flashed onto the hardware, you can just disconnect this board from laptop, just power the board, the algorithm goes on running. Right. So in a nutshell, not just tuning the controllers, you can generate C or C++ code and deploy it onto the hardware. There are various ways to verify the code as well as the algorithm. And later you can generate optimized code. This is production quality code. Please do not mistake with Gen AI generated code. This is the production quality code that can go into the real world application. Right. That's it from my end for today. I am open for any questions you might have.
So one question, why you give the 0.4 value to U for the plant
What is it?
model to convert to
What
linear?
is, what is it?
You have converted the nonlinear plant into linear one for the tuning of the PID, and you give one amplitude value 0.4. Why
Right.
0.4?
So the thing is, we have started the duty cycle of that particular to generate the error, right? I need to generate the data so that when duty cycle is changing, what is happening to the output voltage. So what I did is I just set an offset of 0.5 or 0.4, okay, and then use the amplitude as 0.5. What happens is the duty cycle will start at 50% duty cycle if you are setting offset as 0.5, and then 0.5 plus 0.4 will be 0.9. That means I'm changing the duty cycle from 50% to 90% while for capturing the data to identify a new plant model. So I just set the offset and amplitude while doing that.
We can increase and decrease that range also.
You can change. Yeah, you just do 20% duty cycle to 60% duty cycle. Only thing you need to take care is you change the duty cycle so that the dynamics are captured.
Okay. If I'm giving very large range, they maybe not take the value. It considered as a nonlinear. You have to reduce the range. If that type of error will came,
Come again. I did not get you. Sorry.
you have keep the value between 0.4 to 0.5. If I increase the value from 0.1 to 0.9, then it become nonlinear, I think. The system become again nonlinear.
Yeah, whatever it is. See, you're just changing the data and observing how the system is behaving. Okay. Then you're collecting that data and then identifying a new plant. The only thing that you need to do is the duty cycle cannot go over 100%, which is 1. Okay. Anything between 0 to 1, you change, you do whatever you want. Only thing is when you change, then the actual transient behavior come into picture. That is what we are trying to capture there. It doesn't matter which value you are using, but it should be between 0 to 1.
Okay, thank you, sir.
Any other question from the participants, please? So I think there is no another query, sir. So thank you very
Okay.
much, sir, and for
Thank
delivering
you,
such
everyone. Yeah, thank
insightful and the enriching session, sir, and taking the valuable time from your busy schedule.
No
So
problem at all. Thank you, everyone, for staying back. I hope you are glued to the screen. I
thank you,
hope.
sir.
But if you have any questions later on, also you can just reach out to me. Dr. Preeti ma'am has my contact, so please feel free to
Thank you.
mail me.
Sure, sir. Thank you very much, sir. And we will meeting for another session on the 13th as well.
Yeah.
So thank you very much, sir.
Thank you,
So
everyone.
all participants are requested to please share your feedback on the feedback link that I have shared. And in another 5 minutes, we will be starting the next session for today's FTP. Thank you very much, sir. Sir, before disconnecting, I would like to request all the participants to please switch on their webcams so that we can have the group photograph. All the participants are requested to please turn on your webcam. Thank you very much. Thank you, everyone. So we'll be again connecting at 7:30 and for the next session.
Sure.
Thank you, sir. We welcome you, sir. Professor Ashish Srivastava sir is here with us now. With your due permission, sir, can we start the session? Hope I am audible to all. Ashish sir, am I audible?
Yes, Dr. Preeti,
Okay.
you are audible.
So, with your due permission, may we start the session, sir?
Yes, yes, yes. My voice is audible.
Yes, sir, it is audible, sir. And I've made you the
Camera is
co-host.
also.
Not right now, sir. You are not visible to us.
Okay. Let me check the camera as well.
Maybe the flap of the camera is on the other side.
Yes, yes, I'm just checking it. Just log in again.
Okay. Now you are visible, sir.
Okay, absolutely.
That's better. I'll just again. You are the co-host also, sir. You will be able to share the screen now.
Okay.
So before starting the session, formally I would like to introduce you with our participants. And good evening, everyone. For the next session, we are privileged to have with us the distinguished academic leader and the visionary Professor Ashish Srivastava, sir, who is currently the Professor and Dean Skill Faculty of Engineering and Technology, Shri Vishkarma Skill University, Haryana. Sir is a highly respected academician with extensive experience in engineering education, research, and skill-based learning. Sir has earned his Bachelor of Engineering and Master of Technology degrees with honors in Electrical Engineering from the Government Engineering College, Rewa, MP, and MA NIT Bhopal, MP, respectively. He is awarded PhD on Power Quality Improvements and Lighting Systems from the Department of Electrical Engineering, IIT Delhi, under the supervision of Professor Bhim Singh, sir. He has been conferred with prestigious Posoko Power System Award 2014 under the doctoral category for his outstanding research work focusing on low-cost energy efficient electronic ballast LED driver for low power lighting applications with power factor correction. Sir is currently a skill professor, electrical engineering at SVASU, first government skill university of India established by Government of Haryana. He has a rich experience of 24 years in academics and has published more than 100 research papers in peer-reviewed and indexed international journals of high repute, including IEEE Transactions in Industrial Electronics and IEEE Transaction in Industrial Informatics, etc. With a flair for research and hands-on approach, he acquired expertise in design and implementation of DC to DC converters for power factor correction in many applications such as different lighting loads, SMPS, power supply, electric vehicles, solar PV, UPS, etc. He is the senior member of IEEE and life member of ISCE. Under his supervision, 4 PhD scholars have been awarded the doctoral degree from IIT Dhanbad. Currently, he is supervising 6 research scholars from different universities. His areas of interest include power quality, power electronics and drives, electric vehicles, high-speed energy storage devices, artificial intelligence, deep learning, machine learning, solar PV, SMPS, custom power devices, PFC electronic ballast, BFC LED driver, and PFC DC to DC converters, etc. Today, he'll be enlightening us on a highly relevant and dynamic topic, that is the electric vehicles, current trends and challenges, focusing on the electric motors trends for the electric vehicles. So we welcome you, sir, on this platform, and this is the fourth day of our FDP. So the session is over to you, sir.
Thank you, Dr. Preeti, for giving my introduction to the target audience present in the online mode. So today will be, as Dr. Preeti has told, that we'll be discussing about the electric vehicle, current trends and challenges. So I'm just sharing my slides and checking that everything is perfectly in order. So I hope my slides are visible.
Yes, it is, sir. Please put that on the slide mode. Sure.
I have kept on slide mode. Is it not in the slide mode?
Now it is there, sir. Now it is.
Okay, okay. So, very good evening to every person who is joined in the online mode. The topic of today discussion would be electric vehicle, current trends and the challenges. So, where I'll be discussing about the different motors as well. There are 5 different motors are being used, and what are the history and other associated things that we'll be discussing, along with the what are the other challenges associated with it. Yes, the content of presentation will go as per this slide you can see. After this presentation, you will be able to answer these following questions as an outcome of this presentation: that what is the saving to India on oil import if all fossil fuel vehicle converted into electric vehicle by 2030? So you can certainly able to know what revenue would be saved of India while we are investing, while importing the oil from the Middle East. Then what are the different EV business ideas and opportunities are associated for someone who is looking to go for the startup and their own venture? What are the opportunities in this particular domain? Because this is one of the emerging and challenging area. There are a lot of research is going on, especially in the battery field. What is the best motor technology used for electric vehicles? So there are 5 different motors are being used currently, but the fifth one is very little explored in as far as the application is concerned. Then what are the challenges faced by the EV industry in India? So what are the challenges? Why we could not able to really amplify the presence of electric vehicle on road in Indian context? Looking at the context of the China, they have fully converted all the public transport into the electric vehicle. We also see what is the reason for the slow growth of EV in India. Then what is the comparison of efficiency and the benefits of electric vehicle over the IC engine vehicle or the gasoline vehicle? And we'll also see one of the important part, that who are the 3 Nobel Prize winner in the field of chemistry for the development of lithium-ion battery. So yes, earlier the lead acid battery were being used, but now the lithium-ion is the battery which is being used. And then there are many other batteries also coming into the research, like sodium-ion, magnesium-ion, graphene-ion, aluminum-ion. So these are also into the research with the focus that how much more mileage one can give. So there are 2 things which are associated in the chemistry of the battery: that energy density and the power density. More power density, that can charge faster, and they can discharge in a slower rate. So these are the, I think, few questions you can able to answer after the completion of this presentation. And your queries can be taken in the at the last. Whatever you have, you can pen down the queries, and then I would like to address your queries one by one. So yes, going first, yes, electric vehicle, if you talk about it, is we can say one or the more motors can be used depending upon how much torque you need for the propulsion. So the electric motor, or also it is known as the traction motor, which are being used for the propulsion. So that is known as the EV. So an electric vehicle may be powered with a battery or the solar panel or the electrical generator to get necessary power to drive motors. So EV include but are not limited to road and rail vehicles, even electric aircraft or electric spacecraft, which may be powered through solar and the battery. You can see in the future that the aircraft will be totally flying with the battery support or the solar panel support. So that few photographs I'll be showing you, that people are planning, few countries are planning to go with the aircraft with the full support of the battery and then the solar panel as well. if you look at history, well, EVs first came into existence in the mid of 19th century. Rather, initially it was developed in 18th century. But then at that point of time, the design and the battery were not able to support the enough mileage, and even the speed could not be provided for required for the acceleration of the vehicle. So that's why it suddenly dropped. The idea has been dropped, and then mid of 19th century, then again it has come up. And because of the main two reasons: one, the noise pollution it does not have; the other one, there is no environmental pollution. And secondly, third is most important, it is very cost effective as well in comparison to the IC engine vehicle. Well, if you see, modern IC engine vehicle have been dominant propulsion. That means IC engine were dominating for more than 100 years, you can say. But now it's an electric power is remained common in other vehicle, and such as electric trains. So now trains have been, earlier it was steam trains, then the diesel trains, diesel generator based train. Now you can say the electric trains has also been there from past few decades. Now electric vehicle is the next which is coming up. Electric vehicle, as per our Honorable Transport Minister of Transport, Mr. Nitin Gadkari, he has set a target for Indian context that almost 30% vehicle would be on road would be your electric vehicle. So that is what their target has been set, but we are somewhere close to 5% only. So we are way behind from the target which is being set. So I am telling you the current scenario, which is close to 3 to 4% in the market as of now. What are the electric vehicle? If you say, it is known as the green vehicle because it does not give any pollution to the environment. It does not have any internal combustion engine. All the power which is being provided in the electric vehicle is through the motor, and then through the gear system, the power has been generated. And for that, the motor has to play the key role. And along with the motor, there is a lot of power electronics also being involved. You need DC-DC converter because charging has to be done with the for the battery, which is DC supply you need. But yes, you have to plug in for the charging gun you are putting in the socket is AC powered. So AC power has to be converted into DC. So then AC to DC converter. Then we need to have a DC to DC converter. Question is coming, why we need a DC to DC converter? Because all charger has work on two modes. One is known as the CC mode and CB mode, that is constant current and constant voltage. So initially it should go into the constant current. So battery should be charged for initial 70% charging on the constant current. Then it has to switch from constant current to constant voltage, and the role of battery management system plays an important role while shifting from constant current to constant voltage. So that's why DC-DC converter plays an important role. It is a constant current driver has to be made so that constant current has been supplied, and this is with the basic purpose that it can be done a fast charging. Reason being, batteries are being rated on ampere hour. More ampere if you give, then certainly it can you can say charger in a lesser time. So ampere hour has to be fulfilled. So that's why there are three level of charging. I think you might have heard there is a level 1 charging which is around at 120 volt. Then we have a level 2 charging which is at 240 volt, and then we have a these two are the onboard chargers. The third one is the level 3, where your battery terminals directly has to be accessed for DC terminal. DC supply has to be given, where current is of the order of 500 ampere to even 800 ampere. The moment you do the DC charging at the commercial charging station, the battery would be charged hardly in half an hour. And that is what the target is. But yes, commercial charging infrastructure you cannot establish at home. It is very costly affair. That's why you have to go outside in the market. Well, looking at the overall ecosystem of the EV, well, there are many things which has required. First, if you see, key system players are, there are consumer who has to purchase. Then suddenly, whenever you are going into the market for analysis, and then whenever you are going for the commercial charger, there are many data exchange will happen. Then obviously you need to pay certain penny while charging from the commercial station. Then insurance for the vehicle also is required. Although PUC, you can say pollution under control is not required. Then a lot of technical R&D is going through. Why so? Because customers are still not purchasing enough number of electric vehicle. Reason being, they are skeptical that what will happen if suppose I am going from one city to another city, and then normally if you see in Indian context, the distance between the two cities are somewhere around 350 to 400 kilometer. Though few vehicle recently, if you see the vehicle like your Mahindra XEV 9E, it has claimed 682 kilometer under ideal condition, but actual is around 500 kilometer only. And then if suppose the distance between the two stations are, as I said, 400 kilometer, and suddenly if you feel that you are having on a power mode or a racing mode, it will discharge on a faster rate. So then if you, charging infrastructures are not enough, then you would facing a challenge for recharging it. So that's why R&D is happening in the battery side, most of the R&D, so that they can be give a more mileage in a single charge. Climate change, yes, climate is the most, because that you see already in the NCR region these days, the AQI is most of the time more than 300 or even 400. During Deepavali season, it has gone up to more than 800 or close to 900 and above. So you see, this is not the healthy situation, because what pollution we are giving to the environment, we are inhaling the same air through our lungs. And post COVID, our lungs are not as healthy as it should have been. So now situation is not very, very healthy. So we need to control these pollutants through the as a byproduct. So yes, electric vehicle used to help in controlling to a large extent. Then there are policies. There are many policies are being introduced by government to promote the more and more purchase of these vehicles, so that more vehicle will be on road. And I think you must be aware that the Delhi government has taken a decision that by the next 2 years, by 2027, all CNG buses, DTC buses will be converted, or are not converted, rather will be replaced by all electric buses. And JBM is one of the leading company who has got the major breakthrough in achieving these orders from Delhi government, that they need to generate it, provide rather 10,000 buses to the DTC. Then looking at the major trend, well, you can say there are a lot of vehicle information. Whenever they made any vehicle, they need a lot of data to be flown, so that they can able to see that really if I claim 682 kilometer, whether it runs what really kilometer. Then lithium ion battery, a lot of research is going happening. And then the major challenge which is coming into play is, if most of the vehicle on road will be electric vehicle, that there will be a huge load on our grid. How we can, that demand of the extra power for the charging of the battery will be supplied, so that renewable power, that is mostly the wind and the your solar power, should be tapped for providing the extra demand for more electric vehicle on road. Then smart grid is also one concept which has to be utilized extensively. Then whatever grid supply is available, we should also have a battery energy storage system should be there, so that we can use in the night. And then the concept of building to vehicle, and vehicle and the vehicle to grid, grid to vehicle, which is already there. But then there is another concept of building to vehicle. That means they can make a concept that let's say you are visiting to your office, and they can make a local grid, and you can plug on your battery, and then they can through that local grid convert that DC into AC, and local power they can supply to your offices. And then the moment your battery would be discharged up to rather charging left over up to 20%, then automatically it will be cut off, so that you can again restart. Because once you have to drive your vehicle back to your home, you need to auto start. For that, 20% battery would be more than enough. Otherwise, simply your vehicle is remain idle for 8 hours in the office, and that battery cannot be simple remain in the idle mode. So that is also the concept has been used in the your Germany, which has already developed. Then smart charging, that means you need to reschedule the charging, because all the time grid load, if you increase in the daytime, suddenly it will again create too much load on the grid. We need to make a flat curve, so that load should be distributed in the evening time. So then commercial government has developed a policy that those commercial charging stations, they should be kept the charging rate on the lower side in the night. The way, if you remember earlier, these STD booths were there, And during those night time, after 9 o'clock, after 11 o'clock, the rates have been reduced drastically, and people used to wait in the night time that when rates become one fourth or half, then I'll make my call to my home or my peers if whenever I used to. Similarly, the government has also making the policy that in the night time, late night, the rates will be low, so that most of the people, those can conveniently come in the night time. They can come for the charging of their vehicle in at the commercial charging infrastructure. So this is overall ecosystem where there are a lot of data, a lot of money, a lot of concept will be flowing from one part to the other part. And then looking at the history of electric vehicle, well, as I said, 18th century. In 1837, first electric vehicle, electric car in Aberdeen, Scotland, was being invented by Robert Davidson. Later in 1814, he built a big electric train car. And then 40 years later, almost in 1884, inventor Thomas Parker has created the first electric automobile in London. But again, those design, as you can see in the pictorial representation or through the pictures, these were not efficient design in terms of mileage, in terms of look, in terms of even covering the upper part of the body as well, upper part of the car as well. Then in 1890, almost 50 years later, the first electric car was produced in Iowa, USA by William Morrison. The car was is considered as an electrified wagon, which can carry up to 6 passengers, but with a maximum speed of 14 miles per hour. So that means by this somewhere around 18th century, this idea was explored, could not survive because the design, the battery, the motor, they are not able to really fulfill the requirement what the IC engine could have able to done. That's why almost 100 years the IC engine has a monopoly in this automobile industry. But now electric vehicle is coming forward for this. Similarly, for electrical, but the batteries also has their own history of inventions. First, the non-chargeable battery were developed in 1830, which was purely the lead acid battery. Then the chargeable battery come after that, which was in 1859. Then the deployment of the electric power trains, these batteries have been deployed in 1890. And then 1990, you have seen the lithium ion battery has come, and which has revolutionized the research in the electric vehicle, because the 50% of the cost of the vehicle is basically on the battery itself. Sorry. Currently, I think most of the vehicle are giving the guarantee for around 1,50,000 for the life of the battery. So once you able to exhaust those many hours, those many kilometers rather, those many kilometer, 1,60,000 kilometer or so, Tata is giving. Similarly, Mahindra is also giving nearly the same. Then you need to replace the battery, and the major problem is if the vehicle cost is around 25 lakh or 20 lakh, 10 lakh cost will be for replacing the battery itself. That's why people are quite skeptical whether I should go for electric vehicle or not. Secondly, during the rainy season, you might have visited, you might have seen in many part of India, the underpass areas are fully waterlogged. The Gurgaon is his story everyone knows. In the rainy season, it's more than through 2 feet, 3 feet water logging in the road itself. And then with the electric vehicle, people are skeptical that whether I can go from the underpass where it is completely waterlogged or not. If any drop of water will enter into the battery terminals, although they are quite well designed and well packed, but if water droplets will reach to the terminal, positive and negative terminal of the battery, they will simply short circuit the battery, and then you cannot move even 1 inch further. And that is what people are really that skeptical that whether we should go for purchasing electric vehicle or not. This is what the current scenario of the air quality index, the according to Greenpeace research, and even we are already experiencing current that 22 out of 30 most polluted city in the world are in India. So we are, for the wrong reason, we are on the top 22 out of 30 are in the list. Then nitrogen dioxide, NOx emission, 41% of NOx emission in Delhi were due to the vehicle in 2020. It must have increased in over past 5 years. Then the 23% of PM 2.5 emission is in Delhi were due to the vehicles in 2020. So now this number is increasing. And now you see the graph of the 5, 6 top cities of India. where you can see the estimated death and the cost involved in it. So you can see the death on the road due to accidents are lesser as compared to pollution. And with that data, you are rarely any news agency is publishing on their news channel or in the your newspaper as well. So yes, pollution is one of the big culprit which can really create a lot of diseases like asthma, any other lungs disease. And as I said earlier, also that your lungs are not as healthy post COVID that it should have been earlier. So that means looking at this scenario where air quality index AQI is really alarming number, it is increasing. We need to really think on this movement from gasoline vehicle to the electric vehicle. This is what the carbon emission we are talking about as far as the technology advancement is concerned. If you use an advanced internal combustion engine also, that means new designed IC engine vehicle, you can reduce the carbon emission up to 15%. If you are using natural gas or biofuel, you can have a capacity to reduce up to 30%. If you use a hybrid vehicle where fuel is also there, an electric vehicle, so it would be designed such that at certain speed the motor will be operating your electric vehicle, and then on certain speed it is the fuel which is giving the power to the your vehicle. So in that case, you can have a saving up to 40%. But if you are using a fully 100% your fully electric vehicle, or also another vehicle is a hydrogen vehicle, our Mr. Nitin Gadkari is using coming to the parliament using this hydrogen vehicle only. So this is hydrogen vehicle and fully electric vehicle have a capacity. They can fully reduce the your carbon emission, carbon footprint around 150 to 100%. And that is the task, or that is what we should expect, that we should really reduce the carbon footprint with this vehicle uses. And you can see every home these days, minimum 2 or 3 vehicles are already there. So this is what the scenario. Now, this is what I was talking about, number of death due to pollution. So if you see number of death due to pollution is much higher in India than any other developing or developed country. You see comparison, we are at a 2.51 million deaths. So that's a huge number. If you see the comparison of the 10 countries data, we are much ahead as compared to any other country. So as per studies conducted, death due to pollution in is 8 times higher in India than neighboring country and Pakistan, and more than 20 times than USA. So this is again alarming that yes, deaths, as I said, due to accidents are not more than due to the pollution. And due to the larger population of Indian population density, death occur more often than any other country. So again, the population is, you can say, one of the major region for this higher number of deaths due to pollution. So why we should move towards the EV? Well, there are many reasons which we have already gone through. First is reliability and flexibility. That means it has less maintenance. Electric vehicle has less running cost, though it has a higher initial cost as on did. But with the more intervention of the policies by the government of India, the cost can reduce to the affordable price, and more production of the vehicles, that will also reduce the cost. It was exactly the similar situation whenever new invention come. Like you can see an example of your LED bulb. Earlier incandescent bulb, then CFL, then fluorescent tube, and now the LED bulb. So automatically, the initial cost of the LED bulb was quite high. But now, with the larger production, larger users, larger policies of the government of India, now the cost has come to the affordable price, and also the running cost is pretty much lower as compared to the other sources of light. Similarly, the running cost of your electric vehicle is coming around 1.5 to 2 rupees in comparison to your around 8 rupees to 10 rupees for your petrol vehicle, and 6 to 7 rupees for your diesel vehicle. So that means running cost is the major saving. Affordability, yes, currently this is the challenge because the cost of the electric cars are really high. But yes, with the new model come out, with the cost to buy by the electric cars are government has to come forward to provide more and more relaxation on those policies. Although they have certain policy, but they are not enough to promote more purchase of the electric vehicle on road. Health, yes, this is the major another factor, that it can the tailpipe pollution, which is further leading towards the asthma, heart attack, poor health, premature death. That can certainly reduce if you are using more electric vehicle on road. Then the growing infrastructure. Yes, we need to see the requirement that we need to develop more and more your power supply. That means more and more ways to tap the renewable energy, so that you need to build more and more infrastructure, charging infrastructure, and the same setup of the petrol pump or the diesel pump can be utilized, where you put the solar panel. If it is a coastal area, you can put the windmill, and then you can tap those energies. So this is what the major factor which attracts EVs to be utilized in the market. Well, if you look at the vehicle, the cars are exactly look similar, except the in place of the fuel lid, you will see the charging gun need to be placed. But otherwise, if you look at the outside, it would be looking. People are coming with a more elegant and more beautiful design. Only the change is the charging gun you need to use, whether it's a commercial one or whether you are using your the charging gun which is provided with your vehicle. So one electric vehicle, one charging gun will be provided, which is basically at your home charging infrastructure you have to develop, and then charging gun you need to place it, and it will take around 6 to 8 hours for charging. So cars are exactly looking same, and the major weight of the vehicle is because of the battery pack. Again, you can say the 50% of the weight of the battery is weight of the vehicle is because of the battery only. Similarly, there will be a concept of the trains also you will see, which will be totally battery powered, will be coming in future. Few countries are already running it, where they can fully battery powered trains would be operational. Now, coming to the first question, which I have shown in the first slide, that what is the saving to India on oil import if all fossil fuel vehicle are converted into electric vehicle by 2030? And you will be really shocked to see the number. If we are successful in doing so, that means shifting from electric vehicle, we can save around $300 billion, which is equivalent of Indian rupees of 20 lakh crore in oil import. That much kind of saving we'll do if 100% vehicle by 2030 on the road will be electric vehicle. And what you can save in terms of carbon dioxide emission, nearly 1 gigaton of carbon dioxide emission you can reduce by 2030 if you can able to achieve the converting all vehicle on road as an electric vehicle. And this is the data from the FICCI. So you can say you have a great saving, great future in that way. But yes, whether you can able to achieve that target or not, it's really a challenging task for India to convert 100%. Although it has been said by government of India that 30% vehicle and by 2030 on the road would be the electric vehicles, whether two-wheeler, three-wheeler, or the four-wheeler. Well, what are the advantage of using electric vehicle? Well, they are cheaper to operate. As I said, they are more efficient. Why? Because the motors which we are using are highly efficient motor. The one of the most common motor used for two-wheeler and three-wheeler are PMB LDC motor, and that they have an efficiency of the order of 95% to 97, 98% even. So it's a very highly efficient motor. So that's why you can have less losses. So, and because of which less running cost. So that is what the advantage using these electric motor. And you can have only, while charging, you have a one third as much as per kilometer to purchase fuel. So you have much reduced running cost. You can say one third of your actual running cost of the petrol or diesel vehicle. Cheaper to maintain. There is no, you can say, combustion of the fuel. There is less moving part. There is no injection system, fuel injection, exhaust system. So because of which you can see there are many parts are now there in the electric vehicle. That means there is no IC engine vehicle. So no maintenance would be required, less maintenance. So unless you can say you are visiting to the low service station in case of servicing. So that's the greater advantage, that it is cheaper to maintain. Environmental friendly, well, it is very much friendly because the byproduct of these, it can suddenly reduce the greenhouse gas emission. And then it is more eco friendly. That's why it is said as a green vehicle or green solution. And then there are many EVs the companies are making using with the waste product, that Ford Focus Electric, which is made by the eco-friendly material, completely recycled and a bio-based material it is being made. Nissan Leaf is the vehicle which is totally made with the recycled plastic bottle and the old car parts. So they are recycling. That means properly they are making a proper waste management also. So they are recycling those plastics and they are using more plastic, more fiber. Reason being, they have to reduce the weight of the vehicle because large weight is carried by the battery itself. So they have no other choice till the new battery invention will come. They have to reduce the weight so that more mileage can be achieved. And that is why they are using the recycling of the plastics and the plastic bottles and other car parts of the your old car parts. So that's why they are trying to make as lesser in weight the body part as possible. There are so many health benefits. If you see the harmful emission, looking at the air quality, they do not produce the carbon dioxide, carbon monoxide, nitrogen dioxide, PM 2.5. So those things are not there in case of as a byproduct of this vehicle. And sorry, the other advantage is there is hardly any noise pollution. Well, few people who are residing in the metro cities, especially the Bombay and Chennai, Hyderabad, Bangalore, they might sing during in the night time also. Those who are having the home near to the highways, they have a restless night. They could not sleep in the night because a lot of vehicles are moving on highways in the night time, and they are mostly the commercial vehicles. So if they have been converted into electric vehicles, certainly you can reduce the noise pollution to a larger extent. So this is also the advantage with your electric vehicle. Now, looking at the another question, that electric vehicle business ideas and opportunities for entrepreneur, that there are so many options are available because this is a very new and latest technology. You can have a production of electric car, scooter, bikes. You might have heard Ether Energy. These are the two gentlemen passed out from IIT Chennai. Those have conceived the idea for this electric scooters, and now they are have very recently launched their IPOs, and they are that business is running really good. So that means you can go for two-wheeler manufacturing unit, but yes, it requires a lot of investment, so you have to look for the investor also, without which you cannot do that. Then you have an electric vehicle charging station, that port and spare parts, that can also be one of the option for becoming an as a business idea or becoming an entrepreneur. Production of spare parts for electric car, scooter, bike, so you can have spare parts also, you can prepare. Then the another important is electric car repair and servicing garage. You cannot find, if you are using your electric two-wheeler, three-wheeler, or four-wheeler, you hardly find enough number of service stations. You need to go to the workshop of the company itself. But for the other gasoline vehicle, you find there are a lot many workshops. The garages are available, repair shops are available roadside. But that is a lot of scope is there that one can still open the electric car repair as well as the servicing garage. Then you can have electric car sales garage or electric car dealership shop. This is also option. Electric car tracker installation. People are these days for tracking. That means you can provide those kind of support through app. So that is also the option. Then sales of electric car customized insurance policy cover, also you can have those kind of support for the electric vehicle only. Then sales of electric car spare parts. Then production of batteries. One can go for batteries because battery is the you can say the major research is going on the battery development. Then electric car battery sales service shop, because it can have to recharge the battery sometime once become deep discharge. So that kind of a charging station also should be there. You can run a fast charging center for electric vehicle, which is a DC charging or level 3 charging. Then there is another concept, that conversion of existing IC engine vehicle to battery based electric vehicle. So that also is there. How someone want to change his existing, who has purchased IC engine vehicle very recently. He does not want to go to purchase a new vehicle because that will involve a lot of cost into it. So he wants to convert IC engine vehicle to battery electric vehicle. So that conversion are also available in the market. So one can look for that option as well. Refurbishing and recycling of electric car battery, how you can refurbish and recycle the same way the mobile is being provided to the customer these days. Online electric car sale business, you can have online sale business as well. Online electric car spare part shop, production of diagnostic equipment. Diagnostic means what is the fault. Fault diagnostics can also be a good option that one can, through the software, who can run the software, you can check whether where, which section and what are the faults are there. You can run an electric car diagnostic center, that is mobile or stationary. Then developing a software also, you can develop the software as per the requirement of the electric vehicle. Then you can have a home solar system with EV charger. You can have home solar installation with the EV charger option. One can have a start blogging also. These days, social media is getting so much popularity. People are putting a lot of reels, blogging. So you can start blogging on electric car related topics, that what new invention, new research, or new things are happening. So that can also be very informative and very, you can say, compensation also can be received if your channel is being monetized. Then start an electric car related television or radio program. One can start, become an electric vehicle consultant or trainer. You can become consultant as well. You can start an electric car magazine business also. And then you can organize at a small level the electric car expos also. Already auto expo by the government and many companies, they are every 2 to 4 years they are doing so. But in the greater Noida, I think in the expo mart they are doing so. But yes, one can go for a small car expo as well at a smaller level. Organize electric car racing competition. One can organize electric car racing competition as well. Supply of different parts and the power banks of your electric batteries as well. Now, moving to the next, that what are the EV share in the market and demand increase with the cost reduction? Well, EV share have increased globally, and this had really spurred number of innovation in EV related technology. For example, as I said, battery technologies are expected to undergo a major transition. A lot of many research is going on. Other than lithium ion, sodium ion, magnesium ion, aluminum ion, graphene is one of the magical material which they are using while coating on the electrode. That increases the energy density and the your power density. So a lot of research is going on at different level. The day someone can develop the battery which can run for 1,000 kilometers in single charge, I think that company will be taken hand in hand by all the automobile industry, and that can really lead in the market. Electric two and four wheeler with driving range and other characteristic comparable to conventional vehicle are available even today. However, cost and charging times are high. So this is what the challenge. Two wheeler and four wheeler you will find more with affordable driving range, because that is preferably you are using two wheeler mostly within the city. In few cases, one is moving from one city to the another city. But yes, Tata has very recently mentioned in the news that they are planning to launch a bike with 500 plus kilometers. Similarly, Hero. Hero has also claimed that they have tested a one two-wheeler which can run around 500 kilometer in a single charge. So the day it will come, that means that would be a great advantage to the end user. The transport department is expected to increase significantly in future, because everyone who is moving from their study to the job, first and foremost choice is purchase a vehicle, whether it's a two-wheeler or the four-wheeler. Now, those are the young generation. They always see that how we can be benefited in terms of the running cost, so that can added advantage to you. And then electric two-wheeler with the more and more production, with the more and more driving range, certainly it can, currently it is suited to intra-city driving since the trip lengths are shorter, but then intercity it can also be utilized if the more driving range are possible with the battery invention. What are the other potential? Well, large scale penetration of EV with require both demand side incentive and improved infrastructure. So one has to change the infrastructure. Government has to change the infrastructure in the larger scale. So that is also the potential in EV sector. High EV penetration will result in increase in electricity demand. As I said, more and more electricity, there would be a more load on our grid. So, and that grid cannot supply or cannot serve that much high demand. So we need to look towards the renewable power, and the microgrid, smart grid, where suddenly the energy sector, there would be a more and more demand, more and more jobs, and suddenly more and more infrastructure development for providing a more electricity. So obviously for electrical engineer, there would be a more opportunities will come into the market. Similarly, the higher penetration of EV can provide the benefit of energy security, which becomes significant from 2025. Energy security means whenever you are charging your vehicle, because you are giving your vehicle to the commercial charging station, he can get many data of your vehicle through your infotainment system. So there also a lot of security threats would also be there. So a lot of scope is there for the person who can cyber security and associated field, someone who is working. So one can able to explore those areas as well. Then EV also result in air quality benefits. So that benefits are already there, which can certainly control the PM 2.5, PM 10 level, and also the other carbon monoxide and the other carbon footprint. So that can really help for breathing the air from the environment to everyone. Then EV offered the opportunity to act as a distributed storage in the urban energy systems. That means which can help in better integration of the intermittent renewable like wind, because wind and solar are not available round the clock. If you are using a battery energy storage system, you can store the energy and in the night time one can utilize. There are many areas where the grids are not available, especially in the northeast area. They are using this nano grid or micro grid concept. Whichever sources of energy is providing the power in the daytime, they store it and then in the night time they are utilizing it. So this is looking at the awareness one has to utilize this concept. Your batteries can really serve the purpose. The role of national government is also significant in setting the standard and regulation for charging infrastructure. So government has to come forward with more and more charging infrastructure. That means more jobs, more incentive for vehicle, more investment in the grid and charging infrastructure of the battery, and then it will certainly give you more option for the jobs as well. So that means it will provide more and more options in terms of the research, in terms of the infrastructure development, in terms of the job to the end user. The government can support research on innovative models for battery. As I said, a lot of research is going on in the battery, vehicle technology, in the motor technology also, improving the availability of the charge. You can recycle, reuse, swapping of the battery also concept is being used in the outside India as on date. Means a charge battery is already there with the vendor. Once you reach to the vendor, he will replace the battery. That means they will give you two batteries. One is charging at the workshop only. You whenever you will have, you need not to recharge. You need to go to the workshop. They will replace the battery, and then you can again within 5 minutes you can again move towards your destination. So this is also, and then another point that government has to also ensure the pricing of the electricity once the penetration of the renewable energy will increase more and more. This is what the clear picture that what is the Indian EV market study with the market potential. Well, EV sale in India crossed 7.5 lakh mark in financial year 2019. But you see the comparison. Below you in the slide EV sale segment, if you see financial year 2019 and financial year 2018, if you see two-wheeler, it was 55,000 nearly, which has gone up to more than 2.5 times, 1,26,000. So two-wheeler purchase has increased drastically from 18 to 19. Similarly, for three-wheeler, there was no three-wheeler purchased in 2018. But yes, 6,30,000 in case of your three-wheeler auto rickshaws. And then if you see for four-wheeler, 1,200 were the your EV sales four-wheeler, and they have gone to 3,600. So though it is being increased, if you look at the percentage, but numbers are so small. So we may say percentage is high, but then looking at the Indian context, the total number of vehicle on road, they hardly have a share as on date is around 3 to 4% of the total vehicle, which is quite less with the target set of 30% by the year 2030. It is pretty less. So it does not really, we are moving on the correct, we can say, pathway. Now, the next most important question looking at the power electronics or the motor engineer or electrical engineer or the electrical or electronic engineer, what is the best, which is the best motor technology used for EV. So there are 5 motors are being used currently, and these are these 5 motors. First is PMBL DC motor, permanent magnet brushless DC motor, very compact, cost effective, and very efficient. Then we have next is permanent magnet synchronous motor, which is known as PMSM. Then three-phase induction motor. Then there are 2 more motors, which is permanent magnet switch reluctance motor and permanent magnet synchronous reluctance motor. The last one is still at the research level, where I think companies are only tested in their prototype. Not no one has used in the real product. Top 4 have been used. The fourth one is using by the Tesla because it is a very costly, very delicate motor and it is a very complex control as well. But other top 3 are being used extensively. PMBLDC motor is being used mostly in two-wheeler and three-wheeler. PMSM is being used in four-wheeler cars as well as buses. Similarly, three-phase induction motor is mostly used in the buses. And permanent magnet switch reluctance motor is also being used by Tesla, Elon Musk in Tesla 3 car, I think. This is what the PMBLDC motor, how it would look like. It's very compact, very rugged, highly efficient, and cost effective as well. So it is used in for two-wheeler and three-wheeler. And for example, few of the examples put in for your reference is Ether Energy scooter using this. Upcoming TVS Crayon is using 22 motors. Hero Electric are using. New electric scooters are also using the same motor, and Yamaha EC03. So these are the few scooters. Similarly, for motorbikes, Torque motors, E-motion motors, Menza motors, and Chinese Evoque motors. So these are using this particular PMBLDC motor. Now the question is, why PMBLDC motors are used in EVs? First is in comparison to the other 2-3 motors, the PMBLDC motors are very efficient. Even more than 90% you can get the efficiency. These days, they have designed with more than 95% also. They are lighter in weight, compact in size, and simpler to control the speed. And even the reverse function also can be easily controlled as compared to three-phase induction motor, because in three-phase induction motor, you have to change the 2 phases. So here it is much easier can be achieved. So that's why they have gained the popularity, especially in two-wheeler and three-wheeler. Now the other change is for China, it has become easy to produce PMBLDC motor in huge numbers. Why so? Because in PMBLDC motor, the first 2 letter PM, permanent magnet, China has gifted with rare earth material as an ore which is available in their earth crust and which can generate those high powerful magnet. So that's why more than 90-95% of these PMBLDC motor have been imported by other countries from China. And China economy is growing because of this particular invention and because of the God gift or rare earth material available for development of the permanent magnet. And they are producing at a low, medium, and high power PMBLDC motor for EV in huge number and supplying all over the world. So that's why they are gaining this momentum of developing their economy to a much faster rate. Motors like PMSM, PM synchronous reluctance motor are much better also in efficiency and no torque, ripple, and less noise. But then they are more expensive to manufacture, and also they are not available in the larger power rating by different manufacturing. So that's why they are not being utilized in two-wheeler and three-wheeler as on date. Well, looking at the another comparison of the cost of the PMBLDC motor, the PMBLDC motor are imported from China. As I said, normally the cost is varies on the basis of the power rating. Normally for 900 watt or 1 kilowatt, you can say PMBLDC motor is normally at around 2,200 rupees. And for 1 kilowatt, at around 2,400 or 2,500. That means 2,500 rupees. But this cost looks to be lower, but it is actually China is charging almost the 3 to 4 times of the charge because they have developed the monopoly. Actual cost for within the China market is 800, but it is 2,400 in the other market. So it means they are charging almost 3 times more than their existing market price. And why? Because they within their country they are the controller and other things they are making it much cheaper because it is in-house only, and for outside they are making in different power ratings and they are making more expensive only because they have a monopoly. So for Chinese market, for Chinese people, it is much, much cost effective. And that's why they have developed all their the two-wheeler, three-wheeler, and the public transport fully electrified. The other alternative, as I said, are PMSM, three-phase induction motor, and permanent magnet switch reluctance motor. Synchronous reluctance, as I said, not being used. It is still in the research paper only. So these three alternatives are available, but then the problem is they are not widely available for individual customer to use as conventional kit or for other purpose. Like they are not available in the wide range of power rating. And once it is not available, certainly you cannot utilize it. But PLDC motors are widely available for conversion of the existing IC engine vehicle, as well as they are for the new electric vehicle also. They are available in the large number of power rating, and they are promoting only because China is promoting only because these vehicle will be using the permanent magnet, and these motors are being developed by China, so they have a monopoly all across. And this is the reason why Elon Musk, because he is one of the richest person of the globe, he has taken an initiative that yes, I'll not dependent on PMBLDC motor, I'll switch to the your even not PMSM, because there also permanent magnet is there. He has given a direction to his research team, R&D team, that they should use the permanent magnet switch reluctance motor and the synchronous reluctance motor. This is the other motor, PMSM motor. It is mostly being used in the motorbikes sometime, but otherwise in the cars and the buses. So if you see, few companies has tested Energica motors and Brahmo Impulse using in the motorcycle, but otherwise they are preferred mostly in the electric cars. Chevy Bolt, Nissan Leaf, upcoming hypercar, Pininfarina Battista, which can get up to 100 kilometers in less than 4 seconds, and then they are Tata Ultra Urban bus. This is being used. It is the three-phase induction motor, which is already there for so long, and it has a very good speed control as well. So it has been used by most of the Tesla motors, Tesla Roadster four-wheeler, Tesla Model S, Tesla Model X, Mahindra E2O, which was the first electric vehicle by the Indian manufacturer. So they are using the same. Mahindra E Verito, Mahindra E Supro, Tata Tigor, Tata Tiago. These all are using, even the Tata Nexon also, they are using the same, these three-phase induction motor. This is, as I said, the permanent magnet switch reluctance motor, PMSRM, is used in Tesla Model 3. The picture is what this is, very unique kind of motor which works on the reluctance concept of the reluctance, and this is being used by Tesla 3, and they are also planning to develop their manufacturing plant at Bangalore in India as well. Fifth one has not been into the manufacturing or utilization in the electric vehicle purpose till date. But yes, at the research level, you can find so many papers based on synchronous reluctance motor as well. What are the challenges faced by the EV industry in India? Well, there are so many, so few we'll be discussing. First is charging infrastructure. The government is not developing enough charging infrastructure, whether it's a level 2 or level 3. So that means they have to take initiative to set up community charging station more and more, so that people will be coming forward for purchasing of the electric vehicle. So this is one reason. Second, people, you may hear so many news that yes, solar power charging station, wind power charging station at the existing fuel station will be developed by the country. But yes, still this idea is on paper only, not being executed as on date. Secondly, mainly the charging infrastructures are developing charging too at public level, which is a big challenge because in India, because it will take huge time, and India has so many vehicles on road. If your commercial charging stations are not developing the type 3 charging station, which is DC charging, then it will take a lot of time. You can't find even the availability of the time that people can give their vehicle for the whole night, and then it will take 4 to 6 hours to charge. That's why it is required that more fast DC charging station, which can charge your vehicle in half an hour and 1 hour maximum, should be available. Though they may take more charging penny from your pocket, but yes, time is more important than anything else in the current context. The other is the cost of charging and high infrastructure requirement for renewable energy based charging are also the biggest factor. That means the initial installation cost is too high, which really poses a lot of problem to the government of India, that they have not able to migrate very smoothly, very swiftly to the developing the charging infrastructure based on the renewable energy. And also the 10% of the charging infrastructure required in India shall be of fast charging and 90% can be of level 2. But it is rather happening in the reverse manner. So this is what the enough number of charging infrastructures, charging stations are not there. Then another challenge, what as per the thought process of Ether Energy Board of Governors, that they have developed their charging infrastructure in Bangalore in the name of Ether Grid, but they have developed this charging infrastructure close to their plant, manufacturing plant, and manufacturing plant is almost 40 kilometers far from the city. So the people who are residing in the city, if they go for charging of their two-wheeler 40 kilometers far from their home, then 40 one way, 40 another way, 80 kilometer, and the normally two-wheeler mileage is 120, 130 or maximum 150 kilometer. So 80 kilometer will be wastage in charging and coming back. So that means they should develop those charging station in the cities, in the locality, the area where people used to reside. But people are doing in the reverse manner with their own convenience. They are keeping close to their manufacturing unit. So that also does not serve the purpose. These are the companies which is being setting up in EV charging station in India who are developing a lot. That means government has given them the authorization that they should develop. So Ethergrid, Exicom, Delta Electronics, Asia Brown Boveri, ABB, Fortum India, Magenta Power, Jeff Point E-Mobility, Midgard Electric, ESL, EV Motor. That means lot many companies have been empaneled by government of India, but still the pace has not been maintained because of slow progress, slow growth from the government sector to the private sector. So that is, if it would have been freedom have been given to the more and more private sector, it could have been done. But yes, with the control of the government, the things have not been moving with the much faster pace. The other major challenge is why the slow growth is the cost of the EV is very high, mainly due to the cost of the lithium-ion battery. So the battery packs are imported, mostly batteries are imported, and the cost is around $275 per kilowatt hour in India, which is much higher. And combining the cost of the GST and the lack of lithium in India, further the cost has been increased. Although very recently we heard that in the belt of Jammu and Kashmir, we have found certain lithium resources under the earth crust. It has been, but yes, still it has to be explored through the mines, whether what is the quality, what is the from the ore, what is available, what is the quality of the lithium, and what is the amount of the lithium available from that core. So that is still to be explored. And most of the EVs, two-wheeler, if you talk about, they are ranging 100 to 150 kilometer, and cost is around, whether two-wheeler, if you talk it, even four-wheeler are around 400 to 500 kilometer actual running cost, and cost is somewhere around 10 to 20 lakh, even 30 lakh. Mahindra is around 30 lakhs. So it is much higher. If you look at in the similar segment, the IC engine vehicle are less costly. So yes, people still don't feel comfortable paying that much penny. And then what will happen after maybe after they run their vehicle up to 1,60,000 or 1,50,000, they need to replace the battery pack fully, and then it will cost 50% of their initial cost. So that really makes the things more and more worst. Now, reason for shift to clean mobility, well, air quality index, why we should move to this EV, because we need to think about the air quality. Air quality is deteriorating like anything. And automobile industry, that means your automobile vehicles, IC engine vehicle are the major reason for these kind of, not the only reason, but one of the other industries are also giving a lot of pollution to the environment. Then the aspect related to the global warming, well, this is also the factor because of the carbon footprint. We need to, because a lot many ACs we are using, that also have a greenhouse gas effect. So, and even summertime we have seen that temperature this time has crossed more than 50. If with this pace We are moving, maybe one day we may reach 55-degree, and then after 1 decade we may go to 60-degree, and then you feel really discomfort to yourself to come out in those scorching heat. So that's why it is the high time that we need to think that how we can reduce these greenhouse gas emission to the environment. There is a need to reduce the dependency of the fossil fuel based economy, because all these crude oil is being imported from the Middle East. And if you see, one of in 2014-15, just for your example, $112 billion, approximately 7 lakh crore rupees, were being invested in the import of the oil. And if you look at any of the scheme which is being run by government, like Mahatma Gandhi National Rural Employment Guarantee Scheme, the budget for 17-18 was 48,000 crore. So that means there is no match, you can say. That means the schemes are per year basis scheme being offered by government of India. Budget is much lesser. The investment per year for the crude oil purchase is much higher. So yes, we need to have self-reliant in terms of these vehicle industry that should be think by the government. They should give more and more support. Some of the Indian cities have the worst noise pollution. So yes, it can help reducing the noise pollution. Now, looking at the government initiative, well, there are few policies has been made by the government. One of the most important is the FAME, foster adoption and manufacturing of hybrid and electric vehicle. So they have made this, which provide incentive for purchasing electric vehicle, but still those incentives are not enough. They need to come with more and more. That's why they have come with FAME 1 and FAME 2. So as per the FAME 1, they have developed a scheme that they provide an incentive of 1,800 to 29,000 for scooter and motorcycle, and around 1.38 lakh for cars. But this is still sufficient looking at the initial cost of the vehicle. So then government of India, other initiative, well, government aims to develop India as a global manufacturing center and R&D hub. That's why they are promoting more and more foreign investment. They said that more and more companies like Elon Musk company, they Tesla and other companies, BYD of China, they are promoting Kia, that they are promoting the other companies. Hyundai, they should come and develop their develop their plant for manufacturing of the electric vehicle in India. Government is also planning to set up R&D center of a cost of around 388.5 million US dollars to eliminate the industries to be at par with the global standard. So whatever the global standard are there, they need to manufacture the electric vehicle of that. So, and also the Ministry of Heavy Industry, Government of India has also shortlisted 11 cities in the country for introduction of electric vehicle in their public transport. So that they are also deciding the coming up the tier one cities, that they should not by choice, by force, that they should transform all their public transport into electric transport. The example is Delhi, as you can see. In February 2019, the government of India approved FAME 2 scheme has also been introduced with a fund of around 10,000 crore for financial year 22-22. So this is, they are coming up with the policy, but still it is not enough which can really promote more and more purchase or the sales of the electric vehicle. So what is the reason? Another question, as we discussed in the first slide, for slow growth. Well, first is the transition from the IC engine vehicle or the fuel-based vehicle is taking place slowly but steadily around the world. So it's that pace, no one can amplify it. Once the customer as a end user, one can develop the confidence, only then they can purchase. For that, battery has to come up with the mileage of around 1,000 kilometers or so. If you see we are witnessing the electric mobility revolution from past few years with the aim to reduce carbon emissions. So everyone is talking about reduce the carbon footprint for a better opportunity for the economic growth. But then how much budget is being incorporated? So for EVs, US 1.2 for $1.2 billion has been invested, and all OEMs in this field, working in this field, announcing the launch of new electric vehicles model. So now these days, you, because of more incentive given by government of India, lot many models you might be seeing recently in past 2-3 years, that many OEMs are saying that they are launching this model in 25 and 26 and 27. So people are waiting that there would be a day where you can find out a vehicle of 1,000 kilometers. The Indian government is also a huge support for vehicle. It is bringing many initiative. FAME 2 scheme with more 10,000 crore fund they have bring in to provide more subsidies. But yes, whether it is enough or not, the time will tell. India needs to identify the opportunity and challenges which can help the first step in the process of the this particular transformation. That means people should think transforming the way in the light source of bulb or your you can say CFL to LED. People have automatically transformed with their understanding the advantage. Similarly, it the end user if are able to understand that there are enough benefit moving from IC engine vehicle to electric vehicle, only then they will really move. Then the electric vehicle sales in 2017-18, both two and four wheeler, according to SIAM and SMEV data, is less than 0.3%. So it is very slow pace. The people are purchasing electric vehicle. Though currently it has gone up to around 4%. As per FAME 2, the EV sale target is 1.5 million by 22. Then the share will be around 2%. By 2025, we have a share of around 4%. And the target was set, as I said, 30% electric vehicle by 2030 must be the electric vehicle. India currently ranked at fourth position in automobile industry, but the sales of IC engine cars alone account around 3.4 million. So it's still between January to December 18. So that means people is still purchasing more and more IC engine vehicle, not the electric vehicle, but rather people think of purchasing the hybrid vehicle because then you have a engine is also there. That means fuel is also there, battery is also there. You would not have a situation where your battery is discharged due to any of the reason while you are on the highway. You have a support of the fuel as well. The other major reason, the EV have high purchase price almost as compared to IC engine vehicle. So electric vehicle cost is almost 1.5 to 2.5 times of the IC engine equivalent model. So this is what the another reason is lack of charging infrastructure in India. Few cities, except few cities, you don't find enough charging infrastructure like Chennai, Bangalore, Hyderabad. You will find out fair number, but otherwise with the current population and the EV on the road, there is not enough charging infrastructure. So they have not been developed all across India. So the government has to think in terms of developing more charging infrastructure. Well, the other is no incentive provided to four-wheeler. As mentioned before, the sales of cars is, that's why IC engine cars is huge. We are expecting as end user more and more incentives should to be given, which is not the case currently. So even Niti Aayog made a proposal to transform existing IC engine based two-wheeler and three-wheeler to 100% electric vehicle. But yes, government has not accepted, and even the current industries, OEMs working in this area have not accepted this particular the concept of the Niti Aayog. So to this proposal, the big and leading manufacturing such as Hero, TVS, Bajaj, Honda opposed the Niti Aayog transition decision, and they have given their own excuses that they do not have the resources, they do not have the technology that they can transform all their existing two-wheeler and three-wheeler IC engine and convert it into the EV based. So these are the few reasons for the slow growth of EV in India. But the three are the major, you can say, the reason which you can see. And now, if you look at the vehicle, the design of EVs are more elegant, more good looking, only because they need to work with the concept that how much lighter weight of the vehicle, because most of the weight is already being taken by the battery pack placed at the bottom part of the body chassis itself. So that's why they try to make it more elegant, more plastic, more fiber, so that it will be more and more lighter in weight. This is what the electric vehicle in initial internal structure is. There is a battery pack at the bottom where the charging lead will be provided. Then you have a DC-DC converter, inverter, motor. So all power electronics where controller design is again a role of an electrical engineer. So that can be used. Many DC-DC converter options are available. 5 motors already discussed. Then you have depending upon the motor, whether three-phase inverter VSI or single-phase VSI can be used. These are the few other inventions which has been took place or being tested. Toyota test a car covered with solar panel to make charging station redundant. So they have make a complete solar at the body at the outer surface itself. So it is being charged with those solar panel, and charging is less charging would be required. So this is what there are many, you can say, inventors are inventing or putting their ideas that what can fit in, what can suits better, and so that their business model can really boom for this particular EV sector. This is also the reverse simple team. Car weight is just 630 kg with car fiber chassis core. जो outer car fiber car chassis weight is only 40 kg. Rest, if you 590 kg is weight of the chassis and the battery pack itself. So it's a very light weight. And once you control the weight, obviously your mileage and your efficiency will also increase. This is another design, new improved electric car by Aptera will, which has a 1,000 mile range. They are claiming, but its speed is pretty low. So it is a solar powered flexi cell based on surface. No charger would be required, and it is 2 seating capacity. Then another model of Aptera EV 3D View. This is again a three-wheeler with very unique design, but again, it cannot give you a very high speed, high mileage. It can provide you, but doesn't provide a high speed. So people are doing a lot of invention in terms of the design, look, appearance, and also the mileage. This is another two-wheeler where it is fully covered. The disadvantage of the two-wheeler that they cannot save from the sun and the rain. That can also be being one of the designer has put in this way that two-wheeler is fully covered, so that would really serve the purpose of saving yourself from the rain as well as from the sun. So this is also one of the design. This is the flying taxi, where we are hearing a lot many ideas that with looking at the traffic situation, traffic jam in NCR, there would be a day in the coming decade or so that where you will see the air traffic controller managing the air taxi, and then you will be moving with those controlled by air traffic controller. The air traffic would be managed, and then you can moving without any traffic jam from one part of NCR to the other part, or maybe from one city to the another city. But yes, then they have to maintain a proper protocol that how you can see the other flying aircrafts and these flying cars. This is also by 2030, one of the countries, the global and arena, there are a few countries have targeted that they can make an electric powered regional flights could be taking off by 2030. That means which will be powered by fully by battery or by the solar cell as a backup. So that would be one day you will see flight fully powered by the electric. And now this is the most important research which is being happening these days, as I keep on talking right from the initiation of this presentation, that latest technology and the battery in the battery for the electric vehicles: silicon based battery, room temperature sodium sulfur battery, proton battery, graphite dual ion batteries, your aluminum ion batteries, your nickel zinc batteries, potassium ion, salt water, paper polymer, magnesium ion batteries. So so many disruptive battery technologies are people are working, many companies are working. So there would be a day you will see that there would be a battery can give you a good energy density, power density with a mileage more than 1,000 kilometer for a car which has a 5-seater capacity or above. So what basically we are expecting from the EV battery manufacturing company, that fast charging is the latest concept. So where EV battery can offer around 80% charge of the battery in 15 minutes. So if you are moving from one city to another city, have a cup of tea in during the break journey, and then if it charge for 80%, that will serve your purpose. So it will certainly give a big boost for people to go for EV rather than worrying about the battery going down. So that means in 15 minutes or even 30 minutes, it can be charged up to 80% from the commercial infrastructure, commercial charging infrastructure. But then government has to develop those charging infrastructure on all the highways, as the highways has been built in past 10 years extensively in a very good shape and design and maintaining a very good level. So similarly, the charging infrastructure can also be developed at level 3. Then certainly people will come forward to purchase EV. In a day, person with its full battery capacity can travel 500 kilometers. Once you can give that kinds of confidence in one go, and he needs to take up rest and 15-20 minutes, again it will be charged. Certainly it will be a win-win situation for the end user, and they can certainly purchase and come forward to purchase electric vehicle. This is what the certain other research The Israel is one of the leading in the, you can say, there are many technologies has been developed in the Israel. It's a very small country, but they are really doing a lot of research. In the defense sector, they are already leader, but in this battery also they have claimed that they have developed a battery which will be charged fully in 5 minutes, but it is prototype. Then another concept of Samsung graphene battery, graphene ball they have placed on the nickel, cadmium, magnesium, you can say chemical, your electrode. If they put a coating of the graphene ball, then it can increase the power density and energy density. So this is also being tested. The AVY in Singapore, they have tested a battery which can charge in 20 seconds, but it is still in the laboratory. It has not come as a product. So these are the few options I have told you. Well, another question was, what is the comparison of the efficiency of IC engine vehicle and electric vehicle? Well, looking at the fuel efficiency, well, petrol engine vehicle is 20 to 30%, and diesel vehicle have efficiency of 25 to 35%, but electric vehicle has an efficiency of 70 to 80%. So huge change, huge difference of efficiency. So this is also the advantage. And this is what the other benefits if you are using from gasoline vehicle where you have a carbon dioxide, nitrogen dioxide, PM level as pounds, this much level would be there. If you are going with the EV charging, it's not fully reducing this because you are charging your vehicle with the thermal power power is being generated by thermal power, and that grid power you are using for charging. Suddenly, you because of these power stations or your power NTPC thermal power plants or thermal power station, these pollutants will still be there in the environment. But if you are using EV is being charged with the renewable energy powers or renewable energies, then certainly you can reduce these carbon dioxide and nitrogen dioxide PM level. You can reduce, which can really help you in terms of the controlling the carbon footprint. Well, the I think the last question was that who are the three Nobel Prize winner in the field of chemistry for the development of lithium-ion battery? Well, these are the three gentlemen, and they have an age of more than 70, all three. One is John Goodenough. He has at age of 97, American professor in the University of Texas in Austin. He is one of the oldest person to receive the Nobel Prize. So people at the age of 97 have developed the battery, which is really commendable. Mr. Stanley Whittingham is the another gentleman, age 77. He is British American professor of chemistry at Binghamton University, USA. He has also contributed in the development of the lithium-ion battery. And the third is the Japanese professor Akiro Yoshinobu from the Mizo University, Nagoya, and fellow of Asahi Kasei Corporation, chemical company in Japan, who these three gentlemen have been awarded the Nobel Prize in the 2019 for the lithium-ion battery. And now these are the just few glimpses I am taking. I think now it's hardly 3 minutes left. These are the few top best two-wheeler which is available. Mahindra E-Verito, four-wheeler rather, Mahindra E-Verito, which is giving 181 kilometer full charge with a 10.39 lakh and 86 kilometer top speed. Mahindra E20 Plus is of 10 kilowatt hour battery, 110 kilometer. Tata Tagore is 142 kilometer with a cost of 11.37. Tata Nexon 312. MG ZS 340 kilometer, Hyundai Kona. As on date, now the Mahindra it becomes 682, but earlier this was the topmost leader, but it was 28 lakhs. Similarly, Mahindra is also around, you can say it is 682 kilometers. If in case of the two-wheelers, well, Ether, many models of Ether 450, Entrance, Okinawa, Tumunwall Sports, E-Pluto, X0, Electric Photon, Okinawa Praise 22 Kaimol Flow. Okinawa Praise is giving around 200 kilometer. But yes, as I said, Honda, Hero, and Tata is claiming that they are developing two-wheeler which can give you more than 500 kilometer. And these are the few other electric scooter companies under Make in India concept, just for your awareness. These are the motorcycle on the India under Make in India concept. And these are the e-bicycle companies. I think with this, I come to the end of my presentation. I would love to answer your queries if any.
Thank you very much, sir. I think there is one raised hand from Dr. Harini.
Yeah, please.
Are you having any query, please? Any query from the other participants also? You may please unmute your mic and may ask.
Yes, ma'am. I have one query from
Okay.
Ashish sir.
Yeah, please.
Myself, Neelam Kesarwani from MAIT Delhi.
Okay.
Sir, much is talked about the e-mobility, like the innovations taking place in the batteries and the motors. But something has been thought about the waste of these. Just like plastic is a very useful thing, but the the piling of the plastics has become a havoc and a problem for the society as well as to the country as well as the world also. But if the after 10 years, 20 years, 30 years, what will be the situation of the wastes of all these,
Very
especially
good
the
question.
batteries?
Yeah, very good question, Dr. Neelam. I think I'll just adding to your question, I have another also concern. I think everyone, if you see at your home, there are more than, I can still bet, more than 10 to 15 mobile phones, whether working or non-working, is still at your home. This is also termed as e-waste. Similarly, though we are moving towards the electric vehicle, battery waste management has to be planned very efficient manner by the government of India and the industry. Otherwise, it would be very difficult because the battery waste is really creating a lot of pollution, whether into the those chemical, if it is being disposed of in the river, in the pond, it will really create a lot of problem to the environment. So yes, your question is quite valid in the context, though in the beginning it will not look as a bigger problem, but yes, in the longer run, going ahead with the 2 decade, 3 decade, all the vehicle all across the globe will be electric vehicles. Certainly, the battery management, battery recycling, those things need to be monitored, to be checked, to be developed such that that's why a lot of research is happening on the battery front, and that's why a lot of research required on battery front. But yes, this challenge, this threat of pollution due to the battery would also be there. So that has to be taken up appropriately from the government front only. But it's a very valid question. Any other query, please?
Mr. Sundar Deepan has raised his hand. You may please ask the question, sir.
Good evening, sir.
Good evening.
Myself, research fellow. Can you clarify that DC to DC converter and AC to AC converter with some clarification, sir?
Yeah, AC to AC is basically cycloconverter. Battery is basically a DC battery, which require a positive and negative terminal. Battery normally being charged with a constant current for initial 70%. Then it moves from constant voltage, CCCV mode normally we say. And whenever you see DC-DC converter, there are so many number of topologies are available, starting from buck, boost, Kirk, Sapix, Zeta, Luo, Lloyd, Shepard. There are a number of topology, isolated and non-isolated. So you need to design in two mode. One is constant current, then the constant voltage mode. So your controller has to sense the current, and current error has to pass through the PI controller if you are using PI, or maybe your digital control. And then comparing the error, you need to give to the PWM that pulse so that your current will be constant. And then the moment 70% of your battery will charge, it is shift from the constant voltage. So DC-DC converters are being utilized as a constant current and a constant voltage driver. And the same concept they are used in the electric, this LED driver as well.
Yes, sir. Yes, sir. In my paper, I have chosen the Sebik Zeta converter. So it is nothing but a bidirectional converter.
Sapix Zeta is a fourth order. There are four passive element, two inductor and two capacitor. So it's a family of the buck boost converter, Sapix and Zeta you are talking about. Kirk, Sapix, Zeta, Luo. All these are fourth order converter.
Yes, sir. Yes, sir. Compared to AC to DC, DC to DC is better. You are
For
concluding.
power factor correction is always better. AC to AC you can use, it will give you AC input, AC output. But for battery you cannot use AC, because then you need to convert AC to DC.
Yeah, yes, sir. Yes, sir. Yes, sir. Okay.
Because
Okay.
battery is requiring a DC, so AC cannot be used. But for all power factor correction purpose, power quality purpose, DC-DC converter extensively used, whether in battery charging, whether you talk about the solar, whether you talk about the LED driver, everywhere it can be used for power quality and ensuring your IEEE 519, 1159, those standards can be fulfilled
Okay, sir. Okay, sir.
for research point of view.
Okay, sir. Another one doubt, sir,
Yeah,
for your
please.
Sir, I belongs to the topic regarding the bidirectional DC to DC converter from vehicle to grid. Can you give any more suggestions to improve that next level? But I have an idea regarding AI techniques, reinforcement learning techniques to meet out the
What you can
stability.
use in the bidirectional, you can use bridgeless topology because normally you are connecting a bridge.
Okay,
If
okay,
you are
sir.
using a bridgeless topology, that means you remove the diode bridge rectifier, then that can add on the research, but then control will become a bit complex. But these days, bridgeless topologies are being preferred over the bridge topologies. So yes, bidirectional is being used whenever you are using vehicle to grid and both power flow in either direction. Then
Yes, sir.
these topologies are being preferred. But you may explore the bridgeless topologies, which are the current trend in the research front.
Bridgeless topology. Okay, okay, okay.
Yes.
Bridgeless topology is particularly any switching devices used.
Then switching devices are these only MOSFET IGBTs are the switching devices, depending upon your switching frequency. If your frequency is more than 40 kilohertz, you have to go to MOSFET. If your frequency is less than 40 kilohertz, you have to use IGBT. Because otherwise in IGBT, conduction and switching losses will increase.
Okay, okay, sir. Sir, by using bridgeless topology, we can rectify the stability and resilience of the grid
Yes,
design,
yes,
sir.
yes. You can improve the stability, but control will become complex.
So control will become complex. Okay,
Complex
okay, sir.
because you are sharing the device. The same MOSFET is shared for rectification and for your bidirectional power flow as well.
Okay, okay, sir. Is there any possibility to use reinforcement technique in the grid side to meet out the resilience?
Reinforcement technique also can be used depending upon what are your exact application area. That can be used.
Okay, okay. These two ideas are better to implement in that research area.
Yes, correct.
Okay, okay. Okay, sir. Okay, sir. Thank you for your valuable suggestion, sir.
Most welcome.
Sir, is there any paper to refer or any?
Yeah. There are for the bidirectional. There are so many papers are available in IEEE. You can see IEEE transaction. You will find so many IEEE Explore. You will find so many papers. If you have a license of your institute, then you can get it. Then you can get it. IEEE lot many papers are there.
Okay, sir. Okay,
Professor Bhim Singh, you will find so many papers.
Okay, sir. Okay, sir.
I was his scholar only.
Okay, sir.
Any other query, please?
Okay, sir. I think, sir, there's no more query. So coming to the end of the session, sir, thank you very much once again on behalf of Sri Vishkarma Skill University. Your science insights on the latest developments, the industry trends that you have shared with us, and the practical challenges in the electric vehicle ecosystems have surely provided our participants with the comprehensive understanding of this rapidly evolving field, sir. I hope all the participants have been benefited from your experience and the expertise in this particular domain. So thank you very much once again, sir. And before concluding, I would like to request you and the other participants to please switch on their webcam. Sir, may I request you to please stop the presentation so that we can take the group photograph, sir.
Sure. Yeah.
Just wait a second. I'll be just clicking the screenshot.
Sure.
Thank you very much to all the participants, and we will be again meeting tomorrow at 6 o'clock. Thank you very much, sir, for your details, sir.
Thank you, Dr. Preeti. Very well organizing this particular event.
Thank you very much, sir.
Congratulations for this particular Atal FDP you have able to fetch from the AICT.
Thank you very much, sir. Thank you. So thank you to all the participants. Feedback link has already been shared in the chat window and the WhatsApp group. So you all are requested to please submit the feedback form. And We will again connect tomorrow at 6 p.m. Thank you very much.
Thank you all the participants for lending your ears and asking your queries. Thank you everyone and best wishes to all.
Thank you.